We request the co-chairperson to please introduce the speaker to the delegates.
Good afternoon, one and all. Welcome back to the post-lunch session. It's my privilege to introduce the session's resource person, Dr. K. Ramesh, General Manager, Central Projects, Aditya Birla Group, Mumbai. Dr. Ramesh has about 3 decades of experience in industrial wastewater engineering. He has vast knowledge in the feasibility assessment, technology selection, design engineering, project cost estimation, implementation and project management of zero liquid discharge based common effluent treatment plants and individual effluent treatment plants for textile, pulp, paper, tannery, pharma, chemical and agrochemical industries. He is an expert member in review committee of the CSIR India. He is also an expert member in academic and research committees in various prestigious institutions. Further, he is reviewer of several peer-reviewed journals. I'm proud to say he is a proud alumnus of our campus. In the recent years, the entire world talks about the sustainability utilization of resources. In this context, we are fortunate to have a right person and experienced person here to share his expertise. Sir, the floor is yours.
Good afternoon to all. So, this is my presentation topic, wastewater treatment, various technologies and application, and wastewater reuse. So, in this presentation, I am going to cover what are the various technologies available and emerging technologies. Recently, we are exploring to implement at industrial scale level, and what are the benefits and pros and cons, and what is meant by generally. Everything will be covered in this presentation. Next. 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 So before going into discuss about various technologies, first we have to understand some basics in wastewater engineering. So there are 2 types of wastewater we are dealing. One is industrial wastewater, another one is sewage. So industrial wastewater is basically generating from any industries, and sewage is entirely different from that industrial wastewater. So earlier there were a lot of disposal methods were there to dispose the wastewater. So one is river discharge, another one is marine discharge, land for irrigation and zero liquid discharge, deep well injection. Among these 5 methods of disposal options, river discharge ruled out because none of the industries meeting the TDS norms of less than 2100 milligram per liter TDS. Marine discharge, still many industrial clusters is adopting that after treatment through various stages of treatment, the treated effluent can be discharged into deep sea subject to meeting the pollution control board standards of BOD, COD and no limit for TDS here. Then next option is land for irrigation in India, this option ruled out. Then next, zero liquid discharge is the emerging technology. Now, almost all industrial clusters, all states and all state governments forcing the industries to implement this zero liquid discharge technology for all types of wastewater. And deep well injection is nowadays not allowed by the any governments and other regulatory bodies. So basically, the ZLD is zero liquid discharge system. It is a basic engineering approach in which wastewater goes through various stages of treatment. So finally, we can recover, reuse products like pure water and salt that can be recycled back to industrial application. So this is the ZLD. Next. So before going to design or selection of any technology, first we have to understand the wastewater constituents. So wastewater constituents means a lot of parameters here I am mentioning here. pH, total dissolved solids, chloride, sulfate, temperature, total hardness, nitrogen, You fit that meter in flow channel or in pipe. So if you set the timer, so it will automatically collect the samples each and every 1 hour or 30 minutes once. And finally, you can get samples in that container. So this is very important slide. Next one. Next. So now we, we are going to discuss about what are the treatment stages for each and every effluent, then what are the technologies available. So this is the wastewater treatment matrix. You can see there are 5 stages of treatment here. So this is applicable for wastewater recycling or zero liquid discharge projects. So first we are doing the preliminary treatment, then followed by primary treatment, then secondary treatment, then finally membrane process, then thermal evaporation. So preliminary treatment is nothing but to reduce the temperature and collect the wastewater in a sump. That is the preliminary treatment. So primary treatment is a treatment, first and foremost treatment stage, where we are adding some chemicals like hydrated lime or sodium hydroxide or metal coagulants like ferrichloride or ferrous sulfates. So in this reaction, all the suspended solids and other impurities getting precipitated as a solid waste, so that we can remove 30–40% biological oxygen demand load and the total suspended solids load, and heavy metals also can be precipitated as hydroxides due to addition of lime or caustic soda. Then secondary treatment is exclusively for, is being used to remove the dissolved organics in terms of biological oxygen demand or and chemical oxygen demand. So these 2 parameters must be removed before going to next stage of membrane filtration system or resource recovery system. Resource recovery, we can recover salts for use. So in the next stage, membrane process. So in membrane process, there are 4 categories of membranes are available. One is ultrafiltration membrane, microfiltration membrane, nanofiltration membrane, reverse osmosis. So these membranes, among these 4 categories, microfiltration and ultrafiltration membranes are used to remove the bacteria and viruses and fine suspended particles from the wastewater before feeding into RO. Nanofiltration is a selective separation of monovalent and divalent salts, and RO is being used to recover water from the wastewater. So this is the overall treatment matrix. Next. So in the primary treatment, the structure like this, like a circular tank, where we are feeding the effluent through the pipes, and parallelly we are adding chemicals like lime and ferrichloride or ferrous sulfate to remove floating materials and other insoluble materials. So there are 2 types of configuration here. One is rectangular type, another one is circular type. So circular type, this is the circular type, is a more efficiency compared to rectangular type. So here we can remove 90% suspended solids from the wastewater. Next slide. So next, this is the very important slide, secondary stage treatment. So most of the industry is having the high organic load along with the inorganic salts. But this BOD, COD removal is being done using this biological treatment. So in biological treatment, there are 2 verticals. One is aerobic treatment, another one is anaerobic treatment. So the slide given here is for suspended culture system with extended aeration type reactor. Here you can see the, in this picture you can see the wastewater is aerated with along with MLSS present in the reactor to remove COD, chemical oxygen demand, and biological oxygen demand. So in this biochemical reaction, so all the organic matter is converted as a carbon dioxide and water. So to carry out that reaction, so we have to maintain some operating parameters like food to mass ratio and MLSS concentration and MLVSS concentration. So here these are the design standards here. 1 kg BOD removal. So 1 kilogram of BOD can be removed from the wastewater, for which we need 1.2 kilogram of oxygen. Similarly, to remove 1 kg of nitrogen from the wastewater, we need approximately 4.17 kilogram of oxygen. In addition to that, we have to maintain the carbon-nitrogen ratio. So for 100 kilogram of BOD, we have to add 5 kilogram of nitrogen, 1 kilogram of phosphorus, so that we can get 98% biological oxygen demand reduction and 90% COD reduction. So this reactor is combined reactor where both nitrification and carbonaceous BOD reaction happening in the same reactor. So this is very important slide. And if you look at the power consumption, because the industrial effluents, treatment is very easy, but the power consumption is very high to treat the wastewater to achieve the pollution control board standards or recycle that wastewater back to the system. So if you look at the power consumption, 1.7 kilowatt hour is required to remove 1 gram of BOD from the reactor. Similarly, air requirement 75 to 130 normal meter cube per kilogram of BOD is required. So this pictures given here is taken from Tirupur industrial textile wastewater recycling plants. Next. So this is another important slide. See, biological treatment system are highly sensitive process. If any upsets in pH or any upsets in organic load or any upsets in the toxicity, so automatically your system will drop. You can't get any reduction. Instead, you can get more odor from the reactor. To test that parameters on daily basis, so these are all the important parameters we are doing in the laboratory. One is settling test. Another one is microscopical examination. So these ciliates are dominantly present in wastewater sludge. If you get this kind of microorganism in your biomass, you can get the BOD reduction 95% above and COD reduction 80% to 90%. So mostly the paramecium is an organism which basically involved in the uptaking of suspended solids from the wastewater. So if you look at the efficiency of the reactor, foot to mass ratio would be 0.06. Then COD in the effluent less than 200 milligram per liter we can achieve. Similarly, BOD, we can get single digit BOD less than 5 milligram per liter. Then one more parameter, mean cell residence time, that is MCRT. It is less than 30 days. Normally for sewage, 30 days is more than sufficient, but if suppose the tannery and textile wastewater having recalcitrant COD, for which we may need 100 days to get the mature cells, then biomass concentration we have to maintain in the reactor 3 to 4 grams per liter. So this is the operation parameters normally we are checking in the laboratory. Next slide. So in the biological treatment, mostly the industrial wastewater, there are 4 types of reactors are being used. One is the moving bed bioreactor. It is an attached culture system. Next one is membrane bioreactor and sequential batch reactor, activated sludge process. So this is the typical view of moving bed bioreactor. It is an attached culture system because the bacterial films getting attached on the surface of this media. So when effluent is passing through that media, bacteria digest the food and reduce the BOD and COD. This is the geometrical view of moving bed bioreactor. This is the simple system, but this technology is applicable only for treating the sewage, like a small 50,000 liters or 1 lakh liters of sewage generating from the apartments where we can use this technology, but for industrial effluents, this is a failure system. I'm not considering this system, or we are not considering this system for any hard effluents. Next. So this is the advanced biological treatment. It is, we can say it is a advanced version of activated sludge process. Here we are using membrane within the reactor. So basically this technology is called as membrane bioreactor MBR. So here both aeration and membrane filtration takes place in the same reactor. It is advanced technology, but this technology we need full automation using the SCADA or PLC, programmable logic control system is required to control this system. Otherwise, by manual operation is very difficult because there are 4 various parameters like auto backwashing of the membrane and removing of the sludge from the reactor is a very challenging task. So this technology is well documented, well proven, but we need full automation. The next slide. So this is the aerial view of sequential batch reactor. So this reactor is similar to other MBBR or MBR, but here it is a batch reactor. Basically, it is a batch reactor. So here there are 4 stages. Initially, effluent collected in one aeration tank first zone. in the second zone getting aerated, then third zone getting settled, then fourth zone is dewatering from the reactor. It is a compact system, well-proven technology. In Gujarat, many plants, many sewage treatment plants adopting this technology. The main advantage is it can adjust the shock load in terms of high flow or high organic load or any high pH fluctuation that can be easily adjusted this technology. But here, again, we need full automation. So manually, very difficult to operate this plant. So we have to integrate with the system, with the programmable logic controller. SCADA system is required to operate this plant, otherwise very difficult to operate. Next. Next. So in the biological treatment, if we charge 1 kilogram of BOD, so automatically it will generate 0.5 kg of excess biomass from the reactor. So we have to remove that excess biomass from the reactor on daily basis. But after removing that, we have to concentrate in this kind of sludge thickness. Basically, is a device or unit process where we are compressing the sludge to a 30% level so that we can increase the slurry consistency before feeding to sludge dewatering system. Next. So this is the sludge dewatering, various technologies generally adopted in industries. So one is belt press. So this is the belt press where one continuous belt is feeding to the system and sludge getting passed through that system and separated with the liquid and solid separate. So this technology, high-end technology, but lot of failures. So we are not recommending this technology. The next filter press, it is a chamber type unit where we can extract the sludge with the 40% solid concentration and 60% moisture. This is the proven technology and economically cheaper compared to other technologies. Then rotary vacuum filter is normally used in pulp and paper industry. And a decanter is normally used in juice and other industries. But for industrial application, filter press is a proven technology. It is basically a device which separates the liquids and solids from the biomass or chemical sludge. Next. So in the biological sludge, you have a lot of energy in terms of if you take 1 kg of biomass where we can get around 2,500 kilocalories of energy. So that can be converted as a methane gas. That gas can be, morning also Sangar explained very well the methane generation and everything. That methane can be recycled, can be reused back to the boilers or other areas. After purifying, after concentrating that methane from around 60% to more than 70-80%. So this is the typical flow sheet of anaerobic digester where we can put all the sludge in the reactor. So during the anaerobic digestion, there are 2 stages of reaction. One is hydrolysis, another one is acidogenesis. Then finally methanogenesis, we can get methane gas. That can be used in the CHP engine, combined heat and power engines, or can be used in the boilers. So this is one of the solids handling mechanism normally adopted in many industries. So if you look at the yield of methane from the biomass, so 1 kilogram of COD, it can generate 360 liters of methane. It is a theoretical value, but if you go for field condition, there may be a 200 liters or 250 liters because the design is very critical design and very difficult to achieve most of the parameters, particularly volatile fatty acid ratio. This kind of technology is implemented in many organic waste industries. Next. So this is the oxidation route of, this is the degradation route of the anaerobic digester, hydrolysis followed by acidogenesis. Then finally methanogenesis, we can get methane from previous product of acetic acid. Next. Next. So after primary and secondary treatment, we can reduce up to 80% of COD reduction, 90-95% BOD reduction. But the COD after biological treatment is very difficult to treat. Basically, we call it as recalcitrant COD. So that COD can be removed only by applying the advanced oxidation technologies. So recently, this Fenton oxidation, electrochemical oxidation and electrocoagulation is normally used to oxidize the organics. So in Fenton oxidation, the reagents basically hydrogen peroxide and iron ferrichloride or ferrous sulfate being used. So during the reaction, hydroxyl radicals is generated. That radicals having high oxidation potential, it will hit the organic matters, and finally COD reduced to single digit or maybe double digit less than 10 milligram per liter. If you look at the cost aspect, operating expenses roughly about 550 to 200 rupees per metric cube for penton oxidation, and capital expenditure roughly about 0.5 to 0.7 CR per MLD. Next, electro-oxidation, it is a proven technology and already is successfully operated in many textile and tannery industries. That is also costs of somewhere around 25 to 50 rupees per meter cube. Then electrocoagulation is a type of same electrochemical treatment. Here we are using sacrificing anode as a anode like a mild steel metal, and cathode we are using SS metal. So when we passing the direct current across the cell potential, the reactor, so automatically that now sacrificing anode getting dissolved, and finally it will react with the pollutants present in the reactor. Finally it converted as a sludge. So this is the proven technologies now currently adopted in many industries. Next. So this is the typical structure of electrochemical reactor. This study I published in the Journal of Environmental Chemical Engineering in the last year. So here, this is the electro reactor setup here. You can see anode and cathode. In the anode side, we are using the titanium metal with mixed metal oxide coating electrodes. On cathode side, normally stainless steel rod is normally used. So here, during this reaction, when we pass the direct current through the reactor, so there are two types of oxidations taking place. One is direct oxidation, another one is indirect oxidation. So indirect oxidation, only chlorine, it will oxidize the some 20–30% of organics. And direct oxidation, where hydroxyl radicals are directly hitting the recalcitrant COD and total organic carbon. So finally, the COD reduced up to 90% level. Then after treatment, that water we can easily pass through the reverse osmosis membrane or nanofiltration membrane, so that membrane fouling cannot be happen. This is the COD reduction and color reduction presented in the graph, and also color reduction in the given in the top graph also. So this is my study I presented the last year in the Journal of Chemical and Environmental Engineering journal. Next. Next. So after various stages of treatment, primary, secondary, and tertiary level, still we are removing the COD and BOD and suspended solids and other pollutants. But the calcium and magnesium are the main salts which are normally creating the problem in any membranes or evaporators, where these two salts getting accumulated because of the, it is basically we call it as scaling potential. So to remove this calcium and magnesium, so we are measuring it as a hardness, but we have to remove these two ions from the wastewater before feeding into any membrane system. So we are using, there are two methods normally used to remove these two ions, calcium and magnesium. One is lime soda softening process, where we are adding hydrated lime and soda ash to remove carbonate and non-carbonate hardness. But the technology generates huge amount of sludge. Sludge handling is very challenging. But alternatively, now the synthetic resins, it is a polymeric resins, now is used in many industries to remove the calcium and magnesium. So this geolite is presented in the central, this picture is, it will take care of calcium and magnesium if TDS level is less than 1000 milligram per liter. But if we effluent having high salt concentration, this resin doesn't work. So alternatively, recently, this weak acid cation resins are normally used in industrial wastewater treatment, particularly to remove calcium and magnesium. So here the functional group is carboxylic acid, so it will exchange with calcium and magnesium. Finally, you can get zero hardness or maybe PPB level, but less than zero. So these are very important resins we have to use in before reverse osmosis membrane process or any evaporation process to prevent scaling issue in the membrane sites. Next. 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 So next, this is the membrane stages. So if you look at the membranes, there are 4 stages of membranes. One is microfiltration, ultrafiltration, nanofiltration, reverse osmosis membranes. So microfiltration and ultrafiltration is nothing but a polymeric membrane. It can remove only the turbidity and suspended solids and bacteria and viruses, but it doesn't remove any salts from the feed stream. But next, the third one is nanofiltration system. It is a membrane, composite polyamide membrane. So this membrane having tendency to selectively separate the monovalent and divalent ions from the feed stream. So which means it allows only sodium chloride salt in the permeate side and rejects all the divalent salts from the reject side. So ultimately you can get a pure brine from the nanofiltration membrane. So this membrane normally used to separate the salts with monovalent divalent salts. Then final one is reverse osmosis. So reverse osmosis is a membrane technology. Now we are using in almost all applications, right from domestic to industrial applications. This reverse osmosis membranes having 2 verticals. One is brackish water membrane, another one is seawater membrane. So brackish water membrane having limitations, it cannot operate more than 10,000 milligram per liter salt. But whereas seawater membrane, it can handle up to 40,000 milligram per liter TDS in the feed stream. Yes. Next. This is the cross-cut section view of one 8-inch element membrane, where you can see the permeate direction tube and water stop, collecting tube, O-ring, pure water. This is the membrane sheet with some nylon net to filter out the suspended solids. Here, we are maintaining cross flow of 10 to 12 liters per meter square per hour. That is the flux rate. So to design the membrane or selecting the right technology or right membrane, we have some softwares, reverse osmosis system analysis ROSA program, where you can feed all your data like feed water parameters like pH, TDS, and chloride, sulfate, all the parameters, so that the software it automatically generates some report where you can see the scaling potential, membrane performance, and the recovery, rejection percentage, everything we can see. So this is the aerial cross-cut section view of one 8-inch membrane. Next. This already we discussed. This is the picture of one ultrafiltration membrane installed in one plant. This is the view of one 8-inch reverse osmosis membrane, industrial RO membranes. Next. So this is the typical installation of reverse osmosis plant or nanofiltration plant, where here you can see the some feed pump with the chemical addition. Here we are adding some antiscalant, some acids or alkali to control the scaling potential. Then we have 5 micron cartridge filter, then feed pump, then membrane skid, where you can see the permeate is the pure water. It is separated from the membrane, and non-separated and highly concentrated steam is coming out as reject or concentrate. That we are handling in the separate system, but permeate can be reused back in the manufacturing process. But to control this entire system, very difficult by manual operations, because a lot of process parameters we have to control, mainly pressure in the feed line and reject line, what is the pressure rating of the membrane, delta pressure, everything. So for which we have some online instruments like digital pressure gauges and conductivity indicating transmitter, CIT, and the FI flow indicating transmitter. It measures the flow of the filter element, how much feed is going and how much permeate is collected in the tube. So that is the monitored by the online instruments. So this is the typical installation of membrane unit. Next. So recently this forward osmosis technology is gaining momentum in many industries now, trying out this technology, because this technology having a lot of, it eliminates a lot of limitations present in the conventional membrane system. So in this system, we are using some draw solution, magnesium chloride in the outside. So when passed through the membrane one direction, feed stream one direction, the draw solution, so automatically all water captured by the draw solution, then draw solution getting diluted, that is concentrated again in the one more reverse osmosis system, then finally we can get permeate. So the main advantage of this system, we can reach up to 20% weight by volume salt concentration, but whereas in conventional membrane only we can reach up to 5 to 7%. So this is the main advantage of this technology. But cost is little bit high, but it is a proven technology. Now almost all industries trying to implement this technology to reduce operating cost in general system. Next. Then one more technology is closed circuit reverse osmosis technology. It is the same conventional RO membrane, but here plant is operated on batch mode until reach the desired recovery. Now few plants already installed this technology, Desolitech closed circuit reverse osmosis. It is also proven. We have taken many trials, around 10, 15 trials in our plants. It is a proven, but we are planning to implement this in future. Next. Next. So in many zero liquid discharge plants, they are having first pre-treatment, secondary treatment, then membrane system. They are recovering about 80-85% pure water from the RO membrane. But 15% highly concentrated steam is coming out from the membrane. That is very challenging to treat using any membrane technology. So to handle that steam, we have thermal evaporators where we are using evaporators where we are evaporating that feed stream by applying the steam at high pressure, 10 bar or 15 bar pressure, so that water getting evaporated, then we can compress the vapor, finally convert as a condensate. That condensate having low TDS that can be recycled back, but from the ME concentrate, there is a lot of salt that can be recovered by using adiabatic chilling system or centrifuge systems. Next. These are all the typical view of evaporation system. Here many types of evaporators available. That selection and design of the evaporator is depends upon your feed water chemistry and your requirement. So basically there are 5-6 types. One is falling film evaporator, rising film evaporator, then forced circulation evaporator, mechanical vapor recompression evaporator, then agitated thin film dryer. So these are all the conventional evaporators normally used in all industrial, mainly the ZLD treatment plant, zero liquid discharge plants. Next. So we are recovering salts from the waste stream, mainly the sodium sulfate salt and sodium chloride salt. At 99% purity, that same salt can be recycled back to process application, particularly for textile. You know, they are adding either sodium sulfate salt or sodium chloride salt for dyeing. But in the effluent, we are recovering both salts, chloride and sulfate, by applying some salt saturation point. Here you can see these are the two graphs. In this graph, it is applicable for sodium sulfate recovery, where you can see maximum sodium sulfate solubility, that is anhydrous sodium sulfate solubility, maximum solubility is 50% in 100 gram of water. But if you reduce the temperature from 50 degree to less than 10 degree, you can get decahydrate salt, that is sodium sulfate Glaber salt, basically Na2SO4, 10H2O. So that salt can be easily recovered by applying this phase diagram or salt solubility curve. But if you look at the sodium chloride, it is independent to temperature. So it is not depends on temperature, but solubility remains same in all temperatures. So to recover the sodium chloride, just we can concentrate up to saturation point of 32% weight by volume. Then you can easily pass through the centrifuge. Then you can get a high pure salt of sodium chloride. So based on these two graphs, we are designing the whole salt recovery systems. Next. So this is some pictures we have taken from the salts recovered from the wastewater. You can see the 99% purity of sodium sulfate salt. That is also 99% purity. So here we are comparing the IS standards. There are two grade salts, IS grade 1, IS grade 2. IS grade 1 is above 99% purity. IS grade 2 is less than 99 or 98% purity, but we are achieving grade 1 salt quality that can be recycled back for the dyeing process or chloralkali. So these are the two pics we have taken from the salt recovery system. Next. So now, this is one of the now emerging technology now. It can replace the thermal conventional evaporators. So basically, this is the membrane distillation unit. Here we are using the membranes to concentrate the RO reject stream without applying steam. Here we can use just hot water at 70-degree temperature. It is a proven technology and cost-wise also very economical. So 2 times cost lower than multiple effect evaporator. So this technology already we validated at our site, and it is proven technology. It can replace the multiple effect evaporator. And yield ratio is 4 liters per meter square. We can extract pure water at TDS of less than 30 milligram per liter. Next. So this is the overall cost computation model. So in the ZLD system, we have the primary treatment and evaporator, crystallizer, RO system, many equipments we are using. So that cost is being calculated based on this, some computational modeling. Finally, you can get some X rupees per meter cube, your treatment cost and investment cost, everything we can do it. For which we are using some softwares to simulate the performance or get the real data. So finally, you can get cost per meter cube. Next. So now there are 2 case studies I have in this presentation. One is Tirupur Textile Cluster Zero Liquid Discharge projects. So we implemented this technology in 2006 when I worked in Tamilnadu Water Investment Company Limited in Tirupur. I was the head design engineering of these 9 projects. In all these projects, we have biological treatment, membrane process, and evaporator system. So in Tirupur, there are 18 common effluent treatment plants currently functioning now, and 70 plus individual effluent treatment plants functioning now. So in Tirupur textile cluster, they are using reactive dyes. To fix the reactive dyes, they are using sodium sulfate salt or sodium chloride salt. So these are all the 2 major pollutants in the textile wastewater. One is highly concentrated dyes and salt. So handling this effluent in ZLD plants is very challenging, and we made a lot of modification in the plant last 5 years back. Now these plants are running. So daily wastewater generation is 100 to 120 million liters per day. Next. So this is the typical treatment scheme for textile wastewater treatment. Here you can see the piping network, all the effluents coming through that piping network. First pre-treatment, then secondary treatment, then polishing softeners, then side stream treatment, then after that reverse osmosis, then water reuse, then finally thermal evaporators. So finally we can get waste salt and glaber salt for reuse. But in this plant still there are 2 challenges are there. One is solid waste handling, another one is the mixed waste salt. So after recovering 80-90% salt, still 10% salt is contaminated with both sulfate and chloride. Now still these salts are getting accumulated in the CETPs, but now Pollution Control Board not giving any permission to dispose such a salt in TSDF. So we are finding some solution for that issue. Then next. Treatment scheme already I explained. So here overall water recovery 98%, salt recovery 80 to 90%. Operating cost 180 rupees per meter cube, and solid waste generation 0.5 tons per day in biosludge and 0.3 tons chemical sludge. So here this biosludge is having high calorific value. That sludge is being generated from biological reactors having 2,500 kilocalories. That sludge now is reused in the boiler along with coal. That chemical sludge coming from the softening system, 0.3 tons per day, is a highly, it's a lime-based sludge. Now we are disposing that, CTP is disposing in the cement industries. That sludge is being co-processed along with raw materials. But we have tried with the conversion of that chemical sludge into construction bricks. We got good results, 15 Newton per meter square value. It is comparable to commercial bricks. But that bricks cannot be used for bearing, load bearing capacity applications, but non-bearing applications we can use. So this is the overall presentation for Tirupur Textile Cluster. Next. already explained. Next. So this is the very important slide you can see. So zero liquid discharge means lot of equipments involved, lot of power consumption, lot of steam consumption. So there is a lot of debate. If we apply the ZLD, lot of carbon emission in the atmosphere is very high. So in that case, we have compared 4 technology options. One is conventional, where you can see carbon emission around 17 tons per annum. But here no water recovery. Next, the existing ZLD plant, carbon emission is 32,000 tons per annum, because we are using coal in the boiler and we are using electricity power from the TAN JETCO. Then third one is with the captive power plant integration, because if we integrate the captive power plant, operating cost is less. Carbon emission is, if you look at the carbon emission is 9,000 tons. So that is also not viable. So finally, we have selected one technology called zero liquid discharge or zero waste salt technology, where we tried with pre-treatment membrane technology like reverse osmosis and membrane distillation with integrated with solar thermal system. So in this option, we did not require any steam or high pressure heating system. But here we can use solar system to generate hot water. That hot water can be used as a heating medium in the membrane distillation. So this is the overall carbon footprint comparison of 4 kind of configuration of ZLD. Next. Next. So here one more video presentation is a 5 minutes video presentation. So earlier I worked with Tamilnadu Water Investment Company Limited, is a government promoted company.
The over 800 textile dyeing units in Tirupur are an important component in the entire chain in the manufacturing.
So earlier I worked with the Tamilnadu Water Investment Company Limited, is a government promoted company where I worked as a head engineering. So during that time, we have done 9 projects at a cost of 500 crore project. So we made lot of modification because of lot of technological challenges in the mature technologies or already implemented technology. Then after that, we made lot of modification in the common effluent treatment plants. Then we got a industrial award, 2014 Best Industrial Award from Water Reuse Federation, Los Angeles, for which we have taken this videograph. So this video is being presented here only for educational purpose, not for any business promotion, because now I am working from different company. So just for academic purpose and students knowledge purpose, this video is now being played.
Tirupur, also known as the knitwear capital and as Dollar City, contributes to $2.25 billion and employs over 600,000 people in the textile industry. The discharge of untreated wastewater from the dyeing units into the river Noyal led to the gradual degradation of the river and polluted the groundwater as well. The local farmers petitioned the courts against the pollution caused by the industry, which ordered the industry to implement zero liquid discharge systems or face closure in 2006. The ZLD project was implemented by Tamilnadu Water Investment Company Limited, TWIC, at a cost of 4,210 million rupees for a combined capacity of 53 MLD for 9 common effluent treatment plants, catering to about 244 dyeing units in the industrial town of Tirupur. Faced with the challenge and lack of technology and experience in ZLD worldwide, the project implementation ran into severe problems, particularly with thermal evaporation of reverse osmosis reject brine, leading to closure of all the dyeing units in Tirupur under the court orders in 2011. Faced with this daunting task under adverse circumstances of court closure and lack of faith on viability of technology, zero liquid discharge, TWIC, in close cooperation with the industry and support of the state government, developed and implemented a unique treated brine reuse technology at an additional cost of 1,500 million rupees for reuse of over 90% of the sodium sulfate salt, along with reuse of 88% of recovered water by a cluster of dyeing units connected to a central wastewater wastewater treatment facility. Underground sewer network for collection of wastewater, equalization tank, biological oxidation tanks, clarifier, tertiary filtration system comprising of quartz filters, decolorant resins filters and softener filters, reverse osmosis system, recovered water distribution system, mechanical vapor recompression MVR type evaporators, brine treatment system. Multiple effect evaporator and adiabatic chiller. Online monitoring with SCADA. This technology not only demonstrates high recovery of water, but also recovery of salts for reuse within the dyeing industry, thereby moving towards zero waste discharge and not just zero liquid discharge. The recovery of water and salt as liquid brine and Glauber's salt makes it commercially viable and sustainable. Global Water Intelligence UK have recognized the Tirupur ZLD project implemented by TWIC for the prestigious Global Water Awards 2014 as highly commended under the Industrial Water Project of the Year category, and has also termed it as a phoenix rising from the ashes of an environmental catastrophe. This ZLD project of TWIC has also been recognized by Water Reuse Association USA as a significant contributor to the community, choosing it as the Industrial Project of the Year 2014. The implementation of ZLD in the CETPs has resulted in stoppage of discharge of dyeing effluents into the river. The Noyal River and its dependents can now look up to a better future.
Next slide. Next. So next, one more case study I have. This is basically related to Kanpur Tannery Leather Cluster project. This project is under execution with support from National Mission for Cleaning Ganga, Government of India. So here in Jajmoy area, there are 400 leather processing industries where they are using basic chromium sulfate and highly concentrated chemicals to tan the leather. To curtail the Ganga river pollution, National Mission for Cleaning Ganga given subsidy of 95% plus 5% ratio to industries to establish 20 MLD tannery wastewater CETP with the treatment scheme, primary chemical treatment, two-stage biological treatment, tertiary treatment for hardness and chromium removal, and followed by UF, and diluted with secondary sewage to meet UP Pollution Control Board norms before discharging into irrigation purpose. So in this package, we have suggested one chromium recovery unit where we considered magnesium oxide as a precipitating chemical to precipitate the chromium as chromium oxide, then convert to a chromium oxide liquor by adding sulfuric acid. That 2.5 ton chromium liquor can be recycled back to industry so that we can avoid chromium pollution in the soil and river. This project cost is roughly about 520 crore. This project now under execution in Kanpur, Jajmoy area. Next. Challenges in wastewater reuse projects. One is understanding the wastewater chemistry is very challenging, and also the effluents are dynamic and pollutant concentration also dynamic. So we need lot of pilot studies and micro and macro level in lab scale and field scale by designing the proper system with right interventions. Then only we can succeed this ZLD project, otherwise definitely will be failure. Then major issues in this all reuse projects is higher OPEX, higher CAPEX, and high carbon footprint, and needs high-end, highly skilled manpower to operate the plant, and need lot of experienced design engineers to design the plant. Then asset management manually not possible, so we have to implement PLC-based SCADA system to control the entire plant in automation. Next. So conclusion is this figure. You can see the system where we integrated all the process parameters like flow, pH, tank levels, and pump operating condition. Everything is integrated to the central server system, from where we can control the entire plant with some control logics. So this is the conclusion overall. Characterization of water and wastewater before designing the system is very important. Then we have to prepare a water balance and mass balance of the entire system. Then we have to adopt relevant standard codes for selecting of materials, material of construction. Then selection of sludgeless technologies for final polishing of the effluent by adopting the advanced oxidation technology. Then implementation of SCADA and the distributed control system to control the plant. Then circular economy approach, where we can we can overcome the twin challenges. One is treatment of the wastewater, then we can recycle the lot of resources back to the industrial processing and manufacturing operations. Next. So thank you very much for the presentation.
Thank you, sir, for elaborately presenting the various processes and technologies widely applied in biological treatment at various industries, illustrating the advantages and drawbacks. We now kindly request the chairperson to outline this technical session.
Yeah, thank you so much, sir.
Thank you.
Any questions from the audience? I'm sure you should be having a lot of questions. Feel free to ask.
Any questions?
Okay, because I am loaded with questions. I don't want to bother sir now. I am leaving it for the floor. Okay, so I'm sure you guys would have heard about Nobel Prize being announced every year, right? You have heard about it? Please raise your hands who have heard about it. Nobel Prize. நிறைய பேருக்கு தெரியவே தெரியாத Nobel Prize. Wow, good. That's good. So when it is announced, we feel யாரோ ஒருத்தர் எங்கேயோ ஒருத்தர் இந்த ஒரு நாட்டில் பண்ணாங்க. So I mean we don't get connected to that, right? So I'm proud to say Dr. Ramesh is your own alumnus. He did his MSc and PhD here. Sir, I have never listened to a session like this. I am teaching for the last 15 years at BITS Pilani, but I have never heard such a comprehensive talk on wastewater treatment.
Thank you very much.
So that shows what is the type of training somebody could be imparted in this prestigious institution, number one. Number two, he is not somebody somewhere in some other country who got something. He is currently the general manager of projects in Aditya Birla Group, which is a very prestigious position. We both belong to the same family, Birla family. So yes. It's a very prestigious position which anybody cannot attain that easily. And see the level of projects he has done. So I really appreciate, sir. Thank you so much for taking your time out and then giving a wonderful thing. I have been, without your permission, I have been taking pictures. So it was a wonderful session. If there are no further questions, we will conclude this session. Then we will, because of the pause of time, we will discuss over the tea.
So So finally, I thank all the audience for listening my presentation patiently for the almost 1 hour. Thank you very much.
Thank you, sir. On behalf of the organizing committee, we request the chairperson, Professor Shankar Ganesh, sir, to honor the speaker with a memento. We are happy to invite Dr. N. Geeta, the head, Department of Zoology, PGSF, to thank the speaker by gifting pleasantries. Thank you, sir. Thank you, ma'am. We hereby heartfully express our gratitude to the speaker, chairperson, and co-chairperson for engaging this technical session. Now we proceed to the next technical session.
To the last technical session, we coordinately invite Dr. S.P. Muthukumar, scientist, Department of Biochemistry, Central Food Technological Research Institute, Mysore, to share his research expertise. With pleasure, we invite Dr. C. Kadirvelan to join this session as a chairperson. And we request Dr. L. Uttra, Assistant Professor, Department of Nutrition and Dietetics, to join the session as a co-person.
We request the chairperson, Dr. C. Kadirvelan, sir, to proceed with the session.
Good afternoon, everyone. I'm very happy to introduce speaker Dr. S.P. Muthukumar, sir. He's my senior, also very good friend. That's why I requested to read his bio sketch in front of you. Dr. Muthukumar, basically a veterinarian, because I know, but everybody. So obtained from degree Veterinary College and Research Institute, Namakkal, and a PhD from IVR, Indian Veterinary Research Institute, Azizat Nagar, Berali, UP. He started his career as assistant professor and hatchery manager at Kerala Agriculture University, and subsequently moved to CSIR Institute, Institute of Genomics and Interactive Biology at Delhi. Later on, he joined as a senior scientist at CSIR, Central Food Technological Research Institute, Mysuru, in 2005. Currently, he is working as chief scientist and professor in Department of Biochemistry. He involved in so many animal models, value addition of agricultural and food waste. Also developed a lot of alternative to animal usage. He has published more than 60 papers in SCI index journals. Also given more than 60 invited lectures in different seminar, conference, and workshops. At present, he has 2 postdoctorate students and 7 PhD students working under him. He has completed more than 20 research projects. He is the fellow of Society for Applied Biotechnology, and more than 10 professional body he is the member and also executive member. At present, he is the executive member of LASA, Laboratory Animal Scientists Association of India. He has very vast experience in handling laboratory animals, also development of alternative animal usage. So I'm very happy, sir, to invite you for this session as a lead speaker. Dear friends, I am sure, because I know Dr. Muthukumar last 20 years, we are going to enjoy his presentation. I'm sure I can assure you 2 things. One, definitely you're going to enjoy the presentation. Second, you're going to limit his presentation within the time. So I'm assure you, okay? Thank you and welcome you, sir.
Good evening, Coimbatore. Good evening, Coimbatore. Thank you. Good evening to PSG. Yes. Oh, that means 90% of the students are from PSG. Because 100% voice was there in Coimbatore. 90% is PSG. That means 10% is the difference. Okay. Now, good evening, Globe, I have to tell, because it's an international conference. Right? Okay. We'll start the presentation. How many of you know this building? It looks like a house or palace? Very good. That means nobody is sleeping. Okay. Actually, it is housing the scientists. Okay, this is the CFTRI, that is Central Food Technological Research Institute. Okay, but we are younger than PSG because PSG born in 1947, we born in 1950. So we are 3 years younger. Okay, first of all, I thank the PSG group, wonderful hall, wonderful environment, and the vision. We thought 1947 India got freedom from the binding, but we got one of the rights, that is education rights. Today India is leading the world because of one and only thing, that is education. Because of the colleges and the universities in India, especially in Tamil Nadu, because of that we Tamil people or we Indians are everywhere. And how any of you know what is the illiteracy percentage in US? Illiteracy. That means they don't know only to sign. Not even past a 10th standard. You go to Google and search. It is 33%. They have not even passed the SSLC. Today in every home we have a graduate at least. Am I correct? Because of the benevolence of many of the visionaries who created the colleges and the institutions like this in our country. You all agree, no? Yeah, thanks to the benevolence of the forefinders, many colleges and universities. So thanks for the trust. Then we will go to the subject. Actually, Dr. Kadivalan sir, thank you for introducing. Basically, I am a veterinarian, but I am fed up of animals. Yeah, next please. So I am looking for alternative to animal testing. Usually I joined in CFTRA as a veterinarian to take care of the animals. So usually that is an experimental facility. Then after going there, I have seen the type of experiments conducted. Maximum we will try by giving anesthetics and analgesics to protect the animals. But some of the times when the animal feel pain, I will feel double pain. Because basically as a veterinarian. So that always give me a thought, why we have to test the animals? Can we have some of the alternatives? So this is one of the topics which is closest to my heart. Still I am also struggling to find the alternatives. Still the journey is going on. So some of the insights of my experience I have put into these slides. Yeah, this is a very good slide. I have to thank my Hindi section of my institute. The true sign of intelligence is not knowledge, but imagination. This is told by Albert Einstein. Because knowledge everybody has. Even if you don't have, Google gives. Right? If you go to Google knowledge, it gives the knowledge. But imagination, now ChatGPT started. Okay. Slowly ChatGPT started. Even before the teacher gives the assignment, students will sit on the ChatGPT, ready to type. Immediately after 10 minutes, everything is over. Again, one more rephrasing software. First take it from ChatGPT, put it in rephrasing, take it out and submit. 0% plagiarism. How we are? We are very, very imaginative people. We are very intelligent people, right? So today it is the world of intelligence, right? So that means what I mean to tell is, after 10 years, 20 years, what is going to happen? We have to think today. Then we are a solution provider. Otherwise, we are a contemporary, we have no innovation, no intelligence, nothing. Okay, so think at least 10 years ahead. Okay, then you can stand well. So 20 years ahead, if you think, you are great. Okay, yeah, next slide. So we will go to the animal models. Okay, which are the animal models used earlier? Ancient models. The first and best animal model is human. Okay, for human medicine, which animal is the best model? Human only. How the rat will give you the medicine? There is one medicine. there is one branch of medicine which has developed based on only human trials. Which medicine? One branch of medicine, like homeopathy, Unani, Ayurveda, yoga, which is the one medicine, okay, which has entirely developed and tested in human, and it came into the practice. Which one? Allopathy? Allopathy is tested in animals or human? Animals, very good. Homeopathy? Don't know. Now only hearing, no. Unani, where is that? Right? Yoga you are hearing. Anyhow, we are celebrating International Year of Yoga, everything. Okay. Yoga first animals did or human did? Animals. We learn from animals. Okay. But the one and only medicine which has been tested in human and practiced in human is Ayurveda. Am I correct or not? Ayurveda, whether it is tested on humans or animals? Humans. That is the only medicine. It's directly from the human. Either the guru, okay, they have tested themselves or on the pupils. That means the students. Or they observed the animals and they learned from them. Then they retested. Then they made the script. Okay, so Ayurveda is the only medicine which is tested on human and it works. Now, if you take the Ayurvedic medicines and put it in animal, it won't work. Because that is a human medicine, right? May or may not. So, earlier, human has been used, they have tested on self, and they have used on the students, and they observed the animals, and later on, once the science developed, okay, then we started using the dogs, because that is the one freely available. Okay. So, especially in European countries, they started using dogs, okay, because otherwise they have to go to the wild and bring the wild animal. But sometimes you will become wild, or animal will domesticate and eat you, right? So, they have used the dogs. Then, they came to know somebody is breeding mice. Actually, it is not, they are not breeding. One of the mice, it has fallen from the roof to the floor. Then a lady who has some love and affection towards the animal, she nursed it. And then once she started nursing, their neighbor, relatives, they came without bread and biscuit. They came and how are you, like that. Maybe they have brought some grain also. Like that they came, then the house owner, she has to vacate and animals are living there. Okay, like that she started breeding, then medical colleges they came to know, then they started using. It's a good model because of short lifespan and easy to handle. Next. So, in the last century, last 100 years, okay, I don't go to the history why animal testing is made mandatory. So, guinea pigs are used, rats, mice, and even primates are also used, right? Next. In the last 2 decades, you would have heard this name, transgenics and knockouts, right? So, these transgenics and knockouts, it made us to understand the science better. Okay, to understand the science. We did not invent anything new or anything we did not discover, but only to understand the science. Okay, because if you only we are trying to understand the body mechanism, still we are understanding why it is happening. Okay, it's very difficult to intervene. Because nature is nature, right? So, transgenic and knockouts, these were the norms, right? Now, next. Now, this 3 R's principle, it is practiced from 1950. That is 3 R's. The first question, whenever you go to the animal experimentation to the ethics committee, the first question they will ask, serial number 8A, why animal usage is necessary for these studies? Okay. So, what they will be, why they are asking that question? Why you are, suppose if you want to develop an anti-diabetic drug, okay, why you want to use the animals? There is no diabetic patients in the world. We are the capital. So why don't you test? And there are many methods to confirm whether it is toxic or not. Even you would have heard LD50, lethal dose 50, right? 50% of the population. Now that word has been replaced by NOEL, no observed adverse effect level. Earlier for LD50 we were using more than 100, 200 animals. Now if you go to ethics committee, they will give only 3 animals to determine the NOEL level. Okay, that's as per the OECD guidelines. Okay, fixed dose study. So like that we are refining day by day, reducing the number usage of animals and then refine the method because we are more advanced. Earlier, if the king wants to know whether his food is poisoned or not, what they will do? they will have some servant, no? With love and affection, they will tell the servant to eat first. With love and affection. Okay. It was one generation. After that generation, once civilization happened, then we used the dogs, okay, cats, to test whether food is of good quality or not, okay. So now we don't need any of those models. We have machines. Okay, if you take the sample and give it to the analysis, yes. Anyhow, you yourself have HPLC GC. Nose is the GC. Tongue is the HPLC. Right? And this is the spectrophotometry, eyes. Everything you have, but now you are artificially intelligent people. You are making, life is artificial and we are the only natural. Okay. So, like that, nowadays we have lot of machines and equipments to detect at micro, nano levels. So, slowly we can give rest to the animals. Okay, yeah, this much time you have taken care. Now we will take care of ourselves. Okay. So, replace the animals whenever it is possible. If it is not possible, then you can avoid using the animals and you can use less number of animals like LD50. Next, refine. That means use fewer number of animals, but give as much as possible less pain and suffering. That is the criteria. Okay, this is the 3 R's. Next. So these are all the generations. Now, where we are. Next. So this is one of the model we developed. So initially, I was thinking that as usually I used to tell, if the elephant cries, you will recognize or not? You will recognize. There will be tears in the eyes, and you will feel, Papa, that the elephant is crying. Okay. If the ant cries, even our house auntie also don't bother. Right? Nobody will bother because we don't know that ant is crying. If you magnify and see in the lens and tell that, yes, ant is crying, then you will tell, oh, you will feel pain, right? So, initially I thought, the chicken embryo, no, if you induce diabetes, it may not feel pain. Now, in the last 1 month back, they told even for chicken embryo, you have to take the ethical committee permission. It is right only. But at that point of time, about say 8 years back, there was not that much of awareness about the embryo as an animal model. So I took in vivo as an in vivo model, and we have tested the drug. Next. We have tested few of the compounds. This is the control, this is the diabetic, and we incubate up to 9 days. Then the embryo will develop, chicks will develop. Then we will give the streptozotocin injection. Then the animal will develop diabetes, okay. And then we will collect the blood and we will be evaluating liver glycogen like that, cholesterol, triglyceride like that. We have done a study to replace the animal model. So this was my earlier first attempt to replace the animal model and make alternative to the animal models. Next. Then we used Drosophila also, Drosophila model. This is the sum of the publications. I don't go in detail. Okay, Drosophila models are very much used in genetic studies, neurological studies. Okay, they are all very good models. Okay, you can use Drosophila models wherever you don't want to use any mammal model, because if Drosophila cries, at present I don't have that much of microscope facility to identify. So time being, I satisfy myself. Okay, Drosophila is happy; it is flying like a flight. Okay. So next. So this is again Drosophila. Next. So these are the few of the papers we published on that. Next. Yeah, next it came C. elegans. That is one generation. After some time, no, after Drosophila, we took C. elegans. It's a small worm. It's a transparent worm. And it can also we can induce Parkinson's disease in that worms, and even neurological model, toxicity you can evaluate. Okay, some of the studies you can evaluate in this, and we have also made some of the publications with using this, especially for pesticides and any food toxins, we use this as a good model. Okay, next. Yeah, this is one of the toxicity studies. Earlier, as I told you, LD50 we were using, where there you can see the mortality of the animal. When we started like that. Then I came to know why this many, you can see there, 9th day, 10th day, 11th day, 12th day, animals are dying. So this earlier when I came, this was the LD50 method they were using. Then we have refined it to use the minimum number of animals as per the OECD. Next. Yeah, this is the reduction method. They'll give only one animal you have to take, and you have to give 5 milligram, and you have to, same animal you can give, if it survives, you can give 50 milligram, 300 milligram and 2000. Once 2000 milligram, the animal is, there is no death, then you can declare that it is a what is that, you can be classified as unclassified or category 5, that is up to 2000 milligram safe. More than 2000 milligram per kg body weight, we never use any of the drugs, so need to test. Otherwise, earlier we are going up to 5,000, 10,000 milligram dosage also. Yeah, next. Yeah, same thing. Yeah, that is the classification. You can see there how the LD50 value can be predicted. Here you can see, then you can reconfirm again with 3 animals, category 1, 2, 3, 4, 5, and you can tell if it is one animal dies, then 5 milligram per kg body weight is the LD50. Like that you can declare. I am not going in detail. Okay, you can refer the OECD guidelines, 423 test guidelines number. Yeah, next. So these are some papers we have done on safety evaluation, because any compound, if it is tested and incorporated in the food, first we have to test for the taste safety, especially for microbes or any of the novel isolates like that. Then usually we used to do the method. Now we have almost minimized a large number of animals. Next. Yeah, this is IGY. I am also happy that in some of the laboratory in your institute you are using IGY. I am happy because this is one of the futuristic technology also. Whenever you go to Sigma catalog or any other catalog, you will see antibodies raised in rabbit, antibody raised in goat, sheep, and mouse, rats, like that. Okay. So that means you will have to inject the antigen to the animal, and you have to collect the blood and you have to purify. And this is one of the wonderful technique where there is no blood is involved. Just you have to take the antigen, give to the birds, and birds will lay the egg. From the egg, you can isolate the IgY antibodies, yolk antibodies. Very simple. It is not very simple. There is a standard procedures are there. Once you standardize, it is very easy. And no blood is involved. Because we have to only one, see in ethics what they will tell, no, giving one injection is acceptable. Giving 2 injections is not acceptable. Okay. 1 prick is okay. So only one time you have to give the antigen and 1 more booster dose. After that you can collect the blood. Otherwise think about every day we will go with the syringe in front of the bird and stand, I want to collect the blood. Anyhow, chicken won't cry because it has nicotine membrane, no? Okay, next. So this is the avian antibodies we developed against Staphylococcus enterotoxin. Like that we started developing some immunosensors so that we can identify, suppose aflatoxin, acrotoxin you want to do, just take the sample. And then you can, if you put it, then you can easily identify with the antibody sedimentation. Yeah, next. Yeah, next came zebrafish. Okay. First ECPCCARE told zebrafish as an alternative to the animal model. Now they have told zebrafish is having a vertebral column, it is sensitive to what is that pain, you cannot use, it is an animal model. Okay. Once they told zebrafish is an alternative, then we started working. Because it's a very good model, because the body is very transparent. You can even, for tumors you can use, and neurology, very, very good model. They are very color sensitive, light sensitive. Okay, and it's a very good model. Only thing is, what is that? Very small in size. It is 1 to 2 centimeter size, and very delicate to handle. It's very difficult to give injections, collecting the blood. But if you have a microscope, little bit of usually it is very difficult for me to handle because my hands are it can't bend. But my, especially UG students and PG students, PG students, MSCs, they are very good in handling. Very small one, because they are very flexible, fingers are very flexible, very easily handled. The way they handle, even sometimes I will amaze. Okay, and this is a very good model for many of the studies. Yeah, next. Yeah, you can see the zebrafish publications, see. 1992 it started, 2014, yes, day by day it is number of papers are increasing. It's a very good model. You can get in the local fish shop also, okay. But only thing is, now you have to take the ethics committee permission. And you have to have the cage, what is that cage also. Yeah, next. Yeah, now, this is in 2019, okay, about 4 years back. US EPA, Environment Protection Agency, okay, in US. Okay, they told eliminate all mammal testing by 2035. Okay, they have, when they told 4 years back, eliminate all the testing. But testing is under whose purview? It is not EPA cannot control the testing, right? Who controls? Next. FDA, United States Food and Drug Administration, they only control the testing. If they tell that to approve your drug, you have to test the animal, you have to test the animal. So, in January 12, 2023, this is all post-COVID experience. Okay, COVID taught the lesson. It has changed the way animal testing was earlier, pre-COVID and post-COVID. Okay, how many of you did not get COVID vaccine? Raise your hand. Everybody got it, right? Is the animals are tested to develop the COVID vaccine? No. Yes. How many animals are used? 3. Only 3 animals are used. 3 mice were used to test any allergenicity or toxicity to see whether vaccine has anything. Okay. Otherwise, but usually what is the procedure to get the approval for a vaccine? You have to test in animal model. At least 2 rodent models you have to test. In that, one should be rodent and one should be non-rodent. 2 animal models you have to test. Then it has to go for phase 1 after IND application. Then phase 2. Then phase 3. After that, it will come to the market. Meanwhile, no population will be there in the world. Right? So, there is a class, if it is very emergent, if it is very public health concern, these routes can be bypassed. Because every rule, there is a overrule, right? So like that experience it gave the confidence saying that slowly we can eliminate. We are thinking about the thalidomide story where the children were, because of the thalidomide, it is a drug which is given for the pregnant woman who is having the, what is that condition, I forgot it. Yeah. So it is given to the pregnant woman. The children born, they had the no legs or shortened legs. Because of that, the animal testing became mandatory, and we are also following that. Okay. Now slowly we are coming out of that. So FDA no longer requires all drugs to be tested on animals before human trials. This is one of the benchmark decision taken by the government. Okay, next. So global animal testing and non-animal alternative testing industry developing strategies 2019 to 35. It has been predicted that it will start. Now we are in the 4 years. Okay. Another 11 more years are there. Slowly we are going to get rid of the animal testing. Okay. So another 11 years going to be the crucial to develop alternative to animal models. Next. Yeah, Netherlands, it is one of the sensitive country as well as animal rights and ethics are concerned. They told 2025 as the first year without regulatory animal experiments. Netherlands thought, US FDA announced it. Okay. One or the other countries, they are very fast. Next. So India also not less. This is the just 15 days back, not even 15 days, 14 days back. January 29, 2023. India takes first step to remove animals from drug testing process. We are also at par. Okay. So what they are telling is, the amendment authorizes researchers to use non-animal and human relevant methods. Non-animal and human relevant. Non-animal means zebrafish and you can take as a non-animal model, C. elegans non-animal, Drosophila like that. But it should be human relevant. That means you have to use the human cells. Otherwise, if you test in Drosophila cells and same thing if you test it in human cells, it may behave differently. Okay. And including technologies like 3D organoids. 3D organoids means we have now only monolayer, dual layer. You can develop a 3-layer, okay, 3-dimensional layers, like skin you want to develop, epidermis, then dermis, okay, then foliates, like that you can develop. An organ-on-chip model and advanced computational methods to test the safety and efficacy of the drugs. Okay, so that means now we have to, further we have to move upon. If we stick on to the animal models, after 2035, you will be searching, where is the animal house here? There will be something else will be there instead of animal house. Next. So this is from CPCCA, okay. That means Committee for the Control and Supervision of Animals, Government of India, which supervises and controls the animal experiments in India. The animals are telling, we don't smoke, we don't drive, we don't wear makeup or perfume, we don't use paint, we don't drink alcohol, we don't drop bombs, we don't take drugs. Just because you do, why should we suffer? Correct, no? Why they have to suffer? Because all the bad things we do, okay, then they have to suffer, then we have to sleep aram se. Right? So with this concern, this is the same thing I had in my mind when I joined the facility. Okay, next. So now, how we are fast transforming Department of Biotechnology under the BIRAC. They have called for proposals establishing preclinical disease models in vitro and in vivo for drug discovery. See, if you see the in vitro models, they told patient-specific disease-derived immortal cell lines. That means you can use the cell lines. Then cell-based assays and high-throughput screening methods, organoid models, and humanized 3D bioprinted models, organ-on-chip models, and in vivo models. If these models are there, they will be giving funding. Now the proposals are submitted, now they are under screening. Okay. Printed means now if you tell liver means immediately in the plate, liver one by one hepatic cells, that like that, portal vein, everything will be printed and your organ will come. Then you can put your compound on test. I will explain later. Next. Oh, this is Mysore Zoo. Okay. So it is only few cities in the country, the zoo is within the city. This is within the city. You can walk from the bus stand to the zoo. It is only just 1.5 kilometers away. And it is a beautiful zoological garden, which houses starting from giraffe, chimpanzee, gorilla, and different type of snakes, birds, everything you can see. They are all maintained in natural inhabitat. That is very important. Okay, only night time they will be caged. And other times it is all free. It is free flowing, free moving. I always admire how they, suppose example, if chimpanzees are maintained, they'll make the tree and they'll make a hollow and inside they'll give the honey, live honey, honeybee comb. And this chimpanzee, they'll go and take it and eat. That much of natural enjoyment they will give. That is an environment enrichment like that. It is very nice. Okay, if you come to Mysore, just don't miss it. It's a very nice place to see. Okay. Yeah, next. Yeah, now whatever I told, it is the present generation. Now, further, next generation, what we are going to do. That means after 10 years, how the things will move around us. Next. This is the slide from one of the paper I have taken. In 1950s to almost 2000, 2010, we are using rat or mice model, right? But now what we are going to use? You yourself has to be tested. First you taste the medicine, then you tell whether it is okay or you are alive or dead. Then who took the COVID vaccine first and then entire country took? Prime Minister has took the vaccine, no? Then only we had the confidence, no? That is the reality. First you take the vaccine, then I will take. Okay. So human is going to be the test animal, testing model in future. Is it possible? How many of you ready that I have a cream. If you apply on your face now, you will be the most beautiful men or women in the world. How many of you ready to take? Nobody will take, no? Right? So what we have to do? Very simple. We will develop a facial skin model. We will put the compound and test it, whether it is allergen, whether it is any immune response or any toxicity, any cells are damaged, what is the degeneration, anything happens, test it. Then if I play that video that it is safe, then slowly you will take nicely without nobody's taking a race. Like that, right? So, like that, it will be happening slowly, because it's very difficult to leave the traditional method and come to the animal models. So for that, what is the solutions available? Next. So this is the history, where we will be having the drug discovery cycle, we will identify the lead compound, preclinical, then clinical, and then one drug. To get one FDA drug approved, at least 10,000 PhDs has to be submitted. Each compound is one PhD. That means 10,000 PhDs if submitted, one drug will come to the market. That also after phase 4, it may be withdrawn also, God only knows. Right? So that much of long distance, almost it will take how many years? 5, 1.5, 6, like, it is almost some 12 to 15 years it will take. It's a long journey. And this much of time now companies cannot invest also. So we need an alternative, right? Next. And many of the drugs fail in the market, in the drug discovery cycle whenever the human trials are coming. The majority problem is toxicology. Okay, many of the drugs which is proved safe in the animals are toxic in human. And it may give some side effects also. Okay. And second one is clinical efficacy. Suppose if you tell this drug is good for hypertension, but that drug may be efficient for some other thing and they can market successfully also. Okay. So sometimes it is the clinical efficacy and it may not cure the diabetes 100%, then they will tell yes, now, because if you are going to the doctor and taking the tablet for headache, okay, if you don't relieve of headache, next time you will scold the tablet as well as the doctor and who has taken you to the hospital also. Okay. So why you have to blame? Because the clinical efficacy is also important, then safety, then PK, clinical PK, preclinical PK, these are all the things which play a role. Next. And most drugs fail for the single reason. Safety, efficacy and dose, this all can be determined with the PK, that means pharmacokinetics study. Okay, that is the single reason. Next. This is the correlation between animal and human bioavailability. Okay, bioavailability means if you take a compound orally, how much it will reach the blood or the target organ. If you see, there is a very random. Could you see any linearity, any pattern? No. That means we can't believe for any drug, neither you cannot believe human or the animal. Okay, for your medicine, if you want to develop any medicine for animal, whom to be tested? You will test a human and then take to animal. Animal only has to be tested. That means human has to be tested. Okay, this is what I want to tell. Okay, next. So, there is one solution is there, okay, to make it. That means human microdosing. What is that? Human microdosing. That means 1/100th of the dose. Actually, we know what is that, we can predict the therapeutic dose. In that 1/100th of the dose, it can be injected to the human or it can be taken orally and it can be traced in the body. So that you can study the pharmacokinetics. No need of using animals. If you want to use the animals, you can use less number of animals, limited preclinical toxicology. So, there will be drug candidates. You will do the screening by in silico and in vitro. Nowadays, if you are isolating a compound, if you give the structure, there are softwares. If you give it, it will tell whether it is toxic or not. It will tell whether it is nephrotoxic or it is, say, hepatotoxic. Like that, it will tell. Like that, softwares are already there. Okay. Scrutineers, they are also market some of the softwares. Okay. You can do some in vitro cell line study also. Okay. In the cell culture, this one. And you can take the promising models. Then you can take to the human drug. And human microdosing, you can see there, it is called phase 0. That means no need of phase 1, 2, 3, it's phase 0, so that where you can confirm. But only problem is you need two equipments. Okay, one is the PET, positron emission tomography, PET scan, we know, no? Almost everywhere it is there, PET scan, right? Other one is you need the accelerator mass spectrometry. These two instruments we need to bring the human microdosing to eliminate the animals. Next. So this is the microdose what I told. It is defined as the less than 1/100th of the dose of a test substance calculated from in vitro and animal models to yield a pharmacological effect with the maximum dose of, maximum it will be 100 microgram. Okay. And a small dose of your own medicine. Okay. Whatever the medicine is going to be developed, same medicine you are going to take 1/100th. Next. Yeah, this is how the protocol will be. Synthesize approximately 5 gram of the drug, any compound, isolate. If you want to do the limited with the 3 animals, if you want to do the preclinical toxicity, yes, you can. Next, you have to carbon label, C14 carbon isotope, you have to label it, you have to bind it, then you have to do the AMS analysis. AMS means accelerated mass spectrometry. The only one problem is, next, this machine. Okay, AMS. Any idea how much this machine costs, AMS? 10 crore. Okay. Totally we have, in the world, we have 50 equipments, AMS, in the world, entire world. Luckily in India we have 2. One we have in Delhi with the Inter-University for Astrophysics, and another one is there in Ahmedabad, okay, in IIT. Only 2 institutions we have in India, okay, this machine. But if we can procure more machines, definitely we can go faster drug discovery. We can lead the world, okay. And human microdosing is a new concept. It is a baby of the 2010, okay. Still not many people has worked upon. Not much research has been started. Only few studies has been started. If we pioneer, whatever the 2 instruments, it is already there. Some studies has been already initiated. Mostly we will lead the world soon. Okay. So only thing is we need 10 crore. Now government DBT has come up with one of the funding opportunity. It is called SATI. That means 5 institutions in a locality, they can join together and propose a funding up to 100 crores for establishing a common equipment centers. Like that they are going to establish. Next. Yeah, this is the image with that machine. Yeah, next. So you can see the compound, how much it is. You can see how much the compound is there and where the compound it has, only the compound in a particular place or only particular, that you can easily, you can see where it is a brain picture. So you can see where it is actually located. Next. Next. Yeah, this is the comparison. When you give 5 microgram or 50 microgram or 500 microgram, the pharmacokinetics is same. Clear? Whether the car travels from Coimbatore to Erode, or bus goes, or bike goes, all are same only, no? Only the load is varies. Okay, that is what in this picture it has been demonstrated. Even if you take a microdose also, and microdose does not tax any toxicity, right? 1/100th of the dose, it will only tell the PK data and the compound where it goes and how many cells it has been killed. Maybe 5 cells it can be killed, then you can multiply it into folds, right? So, yeah, next. Yeah, this is the same correlation. Yeah, next. Next. Yeah, so, now the question is, IND. IND is a word that means inventional new drug. When you go for the approval from the CDSCO, that means Central Drug Safety and Standardization Central Drug Standardization and Control Authority, okay, organization. When you go to them, you have to submit an application. What they will ask, first question they will ask, no? Did you test in one rodent and non-rodent animal? Give the report. For time being, till 15 days back, they have asked the question. Now, the trend is changing. Okay. You have to use the minimum number of animals, or you can eliminate, they will be more happy with suitable methods. For that, we have to, the procedure should be authorized also, and I will tell you who will authorize the procedures. So, should all new drugs be administered in humans for the first time at microdose level? That's the question. Okay, next. Yeah, this is Chamundeshwari temple. In near Mysore, we have a hill. Okay. It is also just 8 kilometers away. Okay. So, and buses are playing, city buses are playing. It is very good ambience. And it is a hill temple. You can see the steps. There are 1,108 steps are there. If you can walk also. It will take 1 hour, 1.5 hour. 1.5 hour it will take. For me, it will take 2.5 hours. Okay. And it is very nice ambience to early morning visiting is very nice, or late evening also good. But early morning, if you go through the steps, it's very awesome. Okay. Yeah, next. R&D productivity on decline. Structure of DNA day by day. The novelty in the biological area, it is all declining because the science of discovery is almost getting saturated. Now, it is the time for science of delivery. The science we have understood very well, but whether they have been translated into the products, whether it reached the mass, big question mark, right? We are seeing hundreds of theses in our university, right? How many theses reached the common man's hand? 1/10? No. Now, that is why always I tell, see, some of the countries now who is leading above USA, I don't want to name the countries, they are leading above some of the developed countries. What they did is, initially, they just copied what the Westerners done. Okay. After copying, they developed the products. They developed the products, then they marketed. Those are the products you are seeing in the road. Those are the products you are seeing in your plate. Those are the products you are giving seeing in the supermarket with the language which you don't understand. Okay. So today it is the science of delivery. Whatever you do, it has to be translated. Otherwise, it is none other baby, right? So what I mean to tell is now the science of R&D discovery is in decline. So we have to develop faster and reach the goal, right? Next. So the era of animals gone. Next. Next. Human in vitro. Next. This is the new world. Okay. In testing of drugs or any new products, animal testing is over. We need not to tell the animals bow bow and understand what it is telling. Instead of that, we can tell, "Arey yaar, I am feeling pain in this only this hand, not in this hand. I am feeling headache. I am feeling thirsty." Okay. How animal will tell I am thirsty? You have to stand near and watch whether it is going to the water bottle or it is going for the what is the paddy husk, right? So this is the only alternative. Next. Cells. Next. That means human cells. Next. So for that, the only solution is MOOCs. That is, next, multi-organs on a chip. Multi-organs on a chip means one chip, it should contain the mouth, the digestive system, kidney, brain, everything. So if you put one side drug compound, one side you have to collect the stools and the feces. Sorry, stools and the urine. Okay, like that the system should be there. Otherwise you cannot put the human inside the bulb. Then they will put you in jail. Right? So this is the only option. You have to create a mini human on your lab table and you have to test. Is it possible? Only we can tell the man to, and we can put one funnel and put the drug and collect it whatever it comes, right? Yeah, next. This is the system. This is the, you can see here, suppose if it is an aerosol drug, you can put it here and there will be a lung tissue here. Okay. And if it is a oral drug, you can put it here, it will go to the esophagus and gut, then it go to liver, kidney, it will go to the bone, heart, and then it will be contracted and you can collect the outlet, you can collect the leftovers. Okay. Next. Oh, go back. Actually, this paper, it is published in Trends in Cell Biology. Okay. Next. So this is the liver. You can see the plates in the corner. Okay. That contains each and every well. It is like a 96 well plate. Okay. Where each and every well, it contains the hepatocytes, liver cells, hepatic cells. Okay. So liver, you are collecting the cells and you can put your compound and isolate and you can study. Next. Yeah, this is the plate which they have developed. Okay. So one is the inlet, another one is the outlet, and in the middle there will be the cells. Okay. And you can put your what is the test compound, and after metabolized by the liver cells, you can collect it after a particular duration. You can see there. I'm not going in detail. Next. Heart. Okay. Anybody has worked on cardiocytes? You can see the heart like cells are beating. Okay. When you see the cell culture plate, no, it will be like beating, like same like heart only. Okay. Like that heart also they have developed some of the chips. Next. Yeah, this is the heart on a chip model. Okay. See heart beating next. Artery also can be developed. Next. Blood flow. Next. Kidney. Next. Placenta. Okay. Placenta also they have developed a chip model. Next. Lungs. Next. Yeah, next. This is the lung chip. Okay. Clearly you can see that is the compound where you have to drop that, what is that red color, and the other one is the cells. Next. Yeah, this is the instrument, automated. Okay, you can automatically get the readings also. That chip is inserted there in there is a one square rectangle is there, no? You have to put the compound along with the cells, insert, then it will process and it will give you the reading. Next. This is the gut. Next. This is intestine. Okay. Next. Yeah, this is the Nature paper in 2015. They have integrated 3 activities. The center one, what you are seeing in the brain, the last one you are seeing in the mammary gland, and this is the lactate fluids, okay, which is pumping. So like that it can be integrated also. Okay, next. So this is the ultimate dream, human on a chip. If everything is integrated, it is very easy. You can have one instrument, like a one human being on test. Next. Yeah, this is Brindavan garden. The river is the Kaveri river. Okay, the dam you are seeing is the KRS dam. The palace I have shown no first. Okay, the king of the palace, Krishnaraja Vodayar. Okay, he built this dam. Okay, to build this dam, his wife, children, and their relatives, they have kept the gold with the British government, taken the loan, and they built the dam. Today we are all getting Kaveri water because of their sacrifice, their vision. Okay. So this is near that KRS dam. It is about 12 kilometers away from Mysore. This is the park. In old Tamil films, you can see this park. Okay. Nowadays there are many artificial parks, and there is the musical fountain. Now recently it has been renovated. Between 5 to 7, if you visit KRS dam, you can see very nice musical fountain. Yeah, next. So this, yeah, what you are seeing in the list is they are the approved alternate methods, okay, by the European Commission. Okay, even OECD has also approved. Okay, these are the approved method. Like that, no, we have to get approved, and those are the number of publications based on this technique. Okay, that means slowly the publications are coming up. Once they are validated, yes, now you can use for the drug discovery process. But it needs validation. It's a little cumbersome procedure, but if you attempt, yes, we can do it. Next. Indian status, now where we are. These are all history, okay. These are all what is could be to be done, where we are, okay. The first one is NCBS and TAFR. There is one microfluidics and microfabrication facility. They started some amount of work, okay. So they have designed this, what is the chip, and they started, okay. Next. Again in Indians of IIT Bombay, Microfluidics and Biological Physics Laboratory, they also started working to develop if suppose any of you want to develop organ on a chip model, later in vitro human, these are all the laboratories where you can do your PhD or postdoc and you can develop such models, okay. Next. Again, Center for Nanoscience and Engineering, Indians of Science, they also developed some of the chip models. Okay, next. And IIT Madras, one group, ASIS Research Group, and this is a Arikan Laboratories Private Limited is a company incubated at IIT Madras. Okay, one of the alumni scientists, he has started this company, and they are incubated and in IIT Madras with the professor's guidelines, and they are also developing a lab on chip diagnostic models. Now they are in diagnostic models. They are also into the single cell format also. You can see isolation in single cell format, blood plasma, like that they are all doing. Yeah. Next, like that, no, many of the laboratories in India, they started working. This is a growing field. Okay, you need not go for postdoc to do advanced research. You can in India also some of the laboratories, especially mostly in IIT Bombay, IIT Madras, like that. And another two, yeah, next. This is world news. It is in 2019 news. India pushes for animal alternatives in research. Same thing what I told. Yeah, next. Yeah, some of the papers. This is a paper published from Sri Chitrai Tirunali Institute for Medical Science and Technology in Trivandrum. It is under the Ministry of Health and Family Welfare. This is one of the institutions which has been established to develop a medical device. Okay, actually there is a Dr. Achunathan, I think, I could not remember his name. Okay, he is a cardiac surgeon to the Prime Minister of India and you can be part of the developing module. And they are very good in spreading the technology. They will handhold you also. Some of the little bit of funding also they are giving, okay, for young researchers below 35. Next.
Sir, here,
Yeah.
sir. Sir, here.
Over last. That's why egg, no? Now it is the time for omelette. Yeah. Now, this is a area of golden egg period. Whether you cherish it or break it, that is up to you. Next. So, these are all the palaces. This is the Mysore Palace, Maharaja's Palace, that is the Maharani's Palace. This is Prince Palace. That is third daughter of Krishnaraja Vodaya. Okay, that is the CFTRA. Okay. Next. So, to summarize, past we were using human and animals. Presently, we are with the transgenic knockouts, patient-derived xenograft models, CRISPR-Cas9 models, humanized models, zebrafish models. Now, the next generation is human microdosing and organ-on-a-chip model. Hope we will see you there in organ-on-a-chip or human microdosing. Thank you. Next.
Thank you, sir, for delivering an interesting and energetic session, starting from the history of animal models to the list of other alternate options of model organisms, and even about the chip models. Now, I request the chairperson, Dr. C. Kadirvelan, sir, to outline the technical session.
Thank you, sir. Thanks for a nice narration. It's a topic open for discussion. Take one or two questions and you have direct interaction with the sir.
Just 1 minute, one small advertisement. This is the Laboratory Animal Scientists Association. They also promote the alternatives. 30% weightage they will give for the alternatives. Okay, if you have any papers, and the conference is coming next, in which Dr. Kadirvelan and myself are both are in board members. Next. Yeah, this is the journal we are publishing. You can go to the website and you can publish your articles also, anything about animals and alternatives. Next. Yeah, this is the membership, life membership. Now the life membership is 3,000. In December, it is going to be revised to 5,000. Actually, I should not tell, I am telling. Okay. And those who want to become the member of this one, because slowly this association may change into Laboratory, Animal and Alternative Scientists Association also. So you please join this association. The one more opportunity is next. Yeah, they are going to conduct a conference in 10th to 11th November 2023 at Institute of Science, at IIT, J&T Auditorium. Okay. So if you have any papers, you can go to their website and you can submit your abstracts. Okay. So we both will meet you, all people there. Okay. Who are all working on alternatives and animal models. Next. Yeah, thank you. Yeah, no questions, please. Any questions? You can raise your hand, mic will come there. Yeah, please.
Please give mic to him.
Good evening, sir. Glad you are here. Yeah. So my question is regarding multi-organ system. How are you going to replace the role of ECM, sir, extracellular matrix, in multi-organ systems? Like you collaborated all organ systems, though the replacement for ECM and its immunological, serological clarity. Matrix, yes, sir. How can we replace that role, sir?
I have no answer. Only we have to attempt. I never attempted. We are only handling only single cells. Matrix we did not develop. Mostly that papers, if you refer, there may be something. Because that bone structure, no, they have used some of the matrix. I did not go inside. Maybe some nanofibers they might have developed and they would have used. Okay, I don't have an idea. Sorry.
Okay, sir. Okay, yeah. Thank you, sir.
Yeah, if any other questions are there?
Good evening, sir.
Yeah.
You said about for animal model we need ethical clearance. What about the human model? If we are testing it?
Yes, human ethics also. There is institutional ethics committee. Okay. Sometimes if there is an animal authority, they will call us IHEC, Human Ethics Committee. The difference is, in Human Ethics Committee, there is no Government of India nominee. In Animal Ethics Committee, there are 4 people. Because it is 4-legged now.
Okay, sir. Thank you.
So, human ethics, no. Why there is not much stringent? Okay. And only thing is, in human ethics, one advantage is there. You can get the approval from Lakshadweep and you can do the study in Andaman. Only thing is, there should be a doctor there. Under their supervision, you can do it. But animal ethics, you have to do in the same institute. And human ethics is much easy because, will you allow anybody to test upon you? If anything harm comes, either you sue in the court or you will shoot the, that is why. But animals cannot do, no. On behalf of animals, there is some people, okay. Human ethics also, and human ethics, one more point. Example, if a person walks, okay, he spits and leave. If you collect the sample without their identity, you don't need of ethics committee permission. But if you go and ask somebody to spit and collect the sample, you need ethics committee permission. Even if you ask age of a person, it needs ethics committee permission.
Thank you, sir.
Yeah.
Thank you, sir. Thank you very much for our excellent presentation. To conclude this session, SAR narrated this presentation, in vitro and in vivo models, and the current status also. As a take-home message of this session, 3R, that is replace, reduce, refine. One more R, reuse or rehabilitate. That is the fourth R, Government of India insisting. Kindly take this take-home message, dear students. Thank you very much, sir.
If anybody want to contact, you note down my email ID and phone number. Phone number, don't call me, WhatsApp me.
Thank you, sir. On behalf of the organizing committee, we request the chairperson to honor the speaker with a memento. We are happy to invite Dr. Uttara, Associate Professor and Head, Department of Nutrition and Dietetics, and Dr. Prabhakaran, Assistant Professor and Head, Department of Botany SF, to express our gratitude to the speaker with pleasantries. Thank you, sir. Thank you, ma'am. We express our heartfelt thanks to the speaker, chairperson, and the co-chairperson for the technical session. Now, as we have reached the end of the technical sessions for the 2 days international conference, we believe that the participants would have gained exposure in a transdisciplinary manner. We thank all the delegates and participants for sparing your routine to attend the conference sessions. We hope each of you would have gained various insights and useful inputs from all the technical sessions. Once again, thank you all. Now, we will proceed to the valedictory event of this 2 days conference. We are happy to inform that the best oral and poster presentations will be awarded during this session. We request everyone to please stay back. Thank you.
Ladies and gentlemen, distinguished guests, and esteemed participants, a good evening to one and all present here. We are gathered here today at PSG College of Arts and Science, Coimbatore, for the valediction of the International Conference on Recent Innovations in Health and Biological Sciences, organized by Life Science Departments in association with PSGCARE and Indian Immunologicals Limited, Hyderabad. It has been an enlightening and inspiring event filled with knowledge exchange and discussions on cutting-edge advancements in the field. As we conclude this remarkable conference, let us embrace this moment of reflection and celebration. To commence our valediction program, I request you all to rise for the prayer song, a moment of tranquility and spiritual unity that reminds us of the highest purpose of our scientific pursuits. Students from the Department of Carnatic Music are invited to invoke the blessings of the Almighty.
मैत्रीं भजत अखिलहृदयत्री मैत्रीं भजत अखिलहृदयत्री आत्मवदेव परानपि पश्यत आत्मवदेव परानपि पश्यत युद्धं त्यजत स्पर्धां त्यजत त्यजत परेष्वाक्रममाक्रमणं मैत्रीं भजत अखिलहृदयत्री जननी पृथ्वी कामदुगास्ते जननी पृथ्वी कामदुगास्ते जनको देवः सकलदयालुः दाम्यतदत्त दयत्वं जनता श्रेयो भूयात् सकलजनानां श्रेयो भूयात् सकलजनानां श्रेयो भूयात् सकलजनानां श्रेयो भूयात् सकलजनानां
The wearer of smiles and the bearer of a kindly disposition needs no introduction, but is welcome anywhere. I invite Dr. B. Ramesh, Associate Professor from the Department of Biochemistry, to deliver the welcome address and set the stage for this grand occasion.
Good evening to everyone gathered here, distinguished guests and dignitaries on the dais, esteemed researchers, head and faculty members from various departments, scholars and participants. A very warm welcome to the valedictory program of the International Conference on Recent Innovations in Health and Biological Sciences, organized by the Life Science Departments of PSG College of Arts and Science. Today, we gathered here to celebrate the culmination of an eventful conference that has brought together brilliant minds and cutting-edge research in the field of health and biological sciences. Allow me to extend a special welcome to our esteemed guests, keynote speakers, both international and national, who have graced this occasion with their presence. We are privileged to have our Principal Madam, Dr. D. Brinda, whose vision and leadership has propelled not only our conference, but also our institution to great heights. Welcome, Madam. I would like to extend a warm welcome to our esteemed chief guest, Dr. R. Kumar, Scientist G and Associate Director, Head Food Engineering and Packaging Technology Division, Defense Food Research Laboratory, DFRL, Defense Research and Development Organization, DRDO, Mysuru. Sir, your expertise and contribution to the field of food engineering and packaging technology has been exceptional, and we are honored to have you here today. Welcome, sir. We are equally privileged to have Dr. K. Kadirvelu, Scientist F, Interim Director, DRDO, Industry Academia Center of Excellence, DIA COE, Bharatiya University, Coimbatore, along with us. Sir, your role in bridging the gap between industry and academia and fostering innovation is commendable, and we are grateful for your presence. Welcome, sir. I also welcome Dr. Pon Mariappan sir, DRDO, for this valedictory program. To all the distinguished guests, researchers, scholars, and sportsmen who have joined us from various corners of the globe, we extend a heartfelt welcome. Your presence here not only reflects your passion for advancements in health and biological sciences, but also signifies the collaborative spirit that drives progress in these fields. Over the course of this conference, we have witnessed enlightening presentations, engaging discussions, and the sharing of groundbreaking research. It's truly inspiring to witness the collective effort of brilliant minds who strive to shape the future of health and biological sciences. The exchange of knowledge and ideas during this conference has undoubtedly contributed to the growth and development of these fields. As we come together for this valediction program, let us reflect on the invaluable connections we have made, the knowledge we have gained, and the inspiration that will drive us forward. Let us celebrate the achievements of this conference and the incredible potential it holds for the future breakthrough. I extend my welcome and heartfelt thanks to the organizing committee members, faculty members of life science departments and other departments, teaching and non-teaching faculties, volunteers and sponsors who have worked tirelessly to make this conference a grand success. Your dedication and hard work is truly commendable. Before I conclude, I would like to express my deepest gratitude to all the researchers and scholars whose innovative contributions have enriched this conference. Your commitment to pushing the boundaries of knowledge is truly inspiring, and we eagerly look forward to witnessing your future achievements. Once again, I extend a warm welcome to each one of you. May this valediction program be a memorable and fulfilling experience and carry forth the spirit of innovation and collaboration in health and biological sciences. Thank you all.
Every end marks a new beginning. These words perfectly encapsulate the essence of a conference. Now, to offer her valuable insights and perspective, we request our esteemed Principal Dr. D. Brinda to deliver the presidential address.
Distinguished chief guest of today's second day conference valedictory program, Dr. R. Kumar, Scientist G and Associate Director, Head Food Engineering and Packaging Technology Division, DFRL, Mysore. And our most eminent scientist and our proud alumni of this great institution, best friend, Dr. R. Kadirvelu, Scientist F, Interim Director, DRDO, Center for Excellence, Bharatiya University, the esteemed Secretary, Vice Principals, the resource persons, the invited speakers from both the national and international speakers, the guests from various institutions, the life sciences organizing team members, faculty members, and the galaxy of the intellectual participants from different colleges. The main heart of this 2 days conference is our research scholars. Ladies and gentlemen, once again, greetings and a warm good evening to all of you. Now, we all are towards the verge of this international conference, and we all know that a conference is a life wire for all the academicians. So it connects many academicians and scholars to share their views about the theme, whatever they are interested. So henceforth, it builds or it develops confidence to the participants, to the research scholars, to the faculty members. It helps us to learn from each other's view, and which in turn helps them to apply and transform their knowledge, their expertise in the existing process and business models, which will always take a better serve, and it acts as an exchange resources and expectations. So the participants who are here from throughout the globe, I can say, the 65 different institutions are here, along with the PSG Arts College, the students from the life sciences departments, the research scholars. Now we are always in one particular class or in one particular room, where this is a platform for you. I think definitely you all would have shared your ideas. When you come closer, you can definitely share, you could have by this time shared your ideas, your knowledge, and thereby the innovation. So now, as I told you, we have reached the end of the 2 days international conference. Now these 2 days not only will bring you the idea sharing, but it also forms a platform which connects and encourages the collaboration, which is very, very important. The connectivity is very important. The collaboration is important. Above all, the contact which you have developed, the friendship which you have developed in these 2 days. I'm sure that this unique and interesting presentations made by the participants, around 200 oral presentation and 100 poster presentation. So both were made in this conference that definitely would have unveiled the true meaning of the innovation and unfolding the creative application of the ideas, evoking a paradigm shift. So the research, you all know, it's an integral part, an important feature of the learning endeavors, particularly in the PSG College of Arts and Science, in which many research initiatives have been focused over the years. By organizing such type of the conferences, the seminars and workshops periodically, we always make the young minds to expose to the latest innovation and the scientific trends, thereby fostering and furthering research excellence. So for me, the words are not enough to express our sincere gratitude first to all the guest speakers, the eminent resource persons from the various parts of the country, the international speakers from South Korea, from Thailand, from Sri Lanka, and also all the Indian speakers, the research scientists. So my heartfelt gratitude goes to all the guest speakers for sharing their valuable expertise and exuding professionalism. I am also extremely thankful to all the erudite participants from various institutions for their enthusiastic participation, and appreciations also goes to the best paper award for the oral as well as for the poster presentation. So I congratulate all the participants who have taken part in their own expressing or rather sharing their knowledge of the research both by oral and paper presentation. So really all the students who have exposed deserves a lot of applause for their research work. So I'm also confident that these 2 days life sciences conferences would have had a productive discussion, and definitely it would have built an intellectual fire in all the participants, which in turn will always keep you ahead in the technology and in all the ways of the parts of your life. So I express my sincere thanks to the PSG management for laying the foundation for the high quality research and inculcating the research culture among all the stakeholders through PSG Center of the Academic Research and Excellence. Because at this juncture, I wanted to say that the 2 days conference, the international conference organized by the Life Sciences, the 9 Life Sciences Department, is all because of the support given by the PSGCARE, that is the PSG Center for Academic Research and Excellence. And also the support, I should at this juncture wholeheartedly thank the DRDO. So the 3 eminent scientists from the DRDO are here. I should thank Dr. Kadirvelu sir, Dr. Kumar, and also Ponmariyappan sir for their support in funding, because simply conducting a conference will not give value. Some type of the support by the government. So at this point, I wanted to thank the DRDO and also from the TNSCST and TANSKI. They have supported us. With all that, we are also, I'm wholeheartedly, I thank all the sponsors who have contributed for this 2 days international conference, especially our own alumni, Dr. Anand Kumar. He is now the MD of the Indian Immunologicals Limited, Hyderabad, and also Dr. Umakasi from the Florida, and various other supporting funding agencies we have received. So at this point, I wanted to thank each and every one of the supporting and the sponsorships which we got for the smooth conduct of this conference. So this event could not have happened overnight. So at this point, I also want to take this moment to appreciate all the organizing the members, especially the co-conveners, the organizing secretaries, the organizing committee members, each and every faculty member in the Department of the Life Sciences who have really strained their nerve, and they have taken a lead, and also all the students worked for it, the research scholars and all the faculty members, the non-teaching, that is the supporting staffs, all of them were behind this conference. And I really thank and congratulate and appreciate the very motivated and dedicated organizing committee members from the Life Science Department for their unconditional support and extemporaneous coordination throughout the conference and making this conference immense success. So if time is money, then today you have spent millions for us. Thank you, all of you, for making this conference as astounding success. Jai Hind. Thank you.
Thank you, madam, for your encouraging and motivating words. Progress is impossible without change. We have witnessed the power of change through progress throughout this conference. Now it's time to reflect upon and celebrate the milestones achieved. I invite Dr. L. Uttara, Associate Professor and Head of the Department of Nutrition and Dietetics, to present the report of the conference.
Distinguished dignitaries, resource persons, and participants, good evening. For the past 2 days, research community across institutions have been contemplating about scientific innovations, breakthrough technologies, futuristic research potentials in the international conference. Based on this, with pleasure presenting the report. On 14th July, inauguration of the conference commenced at 9:30 a.m. Dr. Victor Aryogedas, Head Department of Biochemistry, PSG College of Arts and Science, welcomed the August gathering, and Dr. J. Sendil Kumar, Head Department of Biotechnology, presented a preamble on the objectives of the conference. Dr. D. Brinda, Principal, PSG College of Arts and Science, delivered the presidential address, and Dr. T. Kannayan, Secretary, PSG College of Arts and Science, Dr. Rudramoody, Director PSGCARE, and Dr. A. Angaraj, Vice Principal, PSG College of Arts and Science, felicitated the event. Chief guest for the inauguration, Dr. V. Selvamuthi, Director General, Amity Directorate of Science and Innovation, Chancellor, Amity University, Chhattisgarh, in his keynote address, urged for quality research and strengthening industry-academia partnership in accordance with social responsibilities. Professor Sultan Ahmed Ismail, Member State Planning Commission, Government of Tamil Nadu, emphasized the need for preserving and adopting traditional Indian knowledge systems for sustainable development. A souvenir was released by keynote speakers and was received by the dignitaries on the dais. Dr. M. Sengutuvan, Associate Professor and Head, Department of Zoology, PSG College of Arts and Science, proposed the vote of thanks. In the afternoon session, Dr. Naren Ramanan, Associate Professor, Center for Neuroscience, Indian Institute of Science, Bangalore, in his research work, reported that modulation of astrocytes to SRF deficient reactive state could be beneficial in neuronal injuries, aging, and neurodegenerative diseases, the research being first of its kind. Dr. Chang Woo Ji, Research Professor, Fisheries Science Institute, Chonam National University, South Korea, compared the traditional methods of biodiversity analysis with environmental DNA metabarcoding to analyze zooplankton diversity and observed higher diversity with ENA metabarcoding, and his findings will be useful for aquatic biology research. Dr. Pon Mariappan Swamy, Scientist, Defense Research and Development Establishment, DRDO Gwalior, gave an insight on research and development of DRDO in rapid detection of high-risk biothreat agents on site. Dr. Kalpani Ratanaike, Deputy HOD, Faculty of Health Sciences, Colombo International Engineering College, Sri Lanka, in her lead talk, discussed about the structural elucidation and anti-inflammatory agent of Acroncia pendulculata, a common plant used in Sri Lankan traditional system of medicine. On 15th July, the session began with lead talk by Dr. Pariyapan, Assistant Professor and Head Department of Biotechnology, Mahashakaram University, Thailand, in which her experience in coming out with a probiotic strain of lactobacillus bacteria, which was used as a starter culture for production of lactomilk, was shared. She also has commercialized the milk with the support of National Innovation Agency, Thailand. Dr. S. Kamalakannan, Professor, Department of Biotechnology, Chonbuk National University, South Korea, has introduced a hybrid model for degradation of xenobiotics, wherein he has combined electrodegradation with conventional biological treatment for more effective bioremediation. Dr. Shankar Ganesh, Associate Professor, Department of Biological Sciences, BITS Pilani, Hyderabad, assessed the effect of aeration on treatment efficiency and microbial community shift in closed landfill leachate generated from municipal solid waste landfills that are closed and capped using SNAD reactors. He concluded that SNAD reactors alone is insufficient for comprehensive treatment of closed landfill leachate and hence to be coupled with reverse osmosis or anaerobic digestion. The possibility of modifying milk using biotechnological approaches to enhance conjugated linoleic acid content was investigated by Dr. C. Kadirvelan, Associate Professor, Tamil Nadu Animal Science University, Namalkal. This milk could probably function as anti-atherogenic, anti-diabetic, and anti-carcinogenic agent. Zero liquid discharge system has been mandated by the state government for industries. Dr. Ramesh, General Manager, R&D, Grasam Industries, Aditya Birla Group, Mumbai, discussed about the various technological options available for wastewater recycling and pollutant removal and appropriate sampling methods for characterization. He insisted on exploring the possibility of recovering salts such as sodium chloride and sodium sulfide for reuse from the sludge generated. The presentation by Dr. S.P. Muthukumar, Senior Scientist, CFTRA Mysuru, focused on drug discovery process, correlation between animal and human bioavailability, and alternative approaches in animal testing and validation. A total of 640 participants from 60 different institutions across 4 states registered for the conference. Academicians and researchers were given the opportunity to present their research work through oral and poster presentations. Thank you.
Thank you, Madam. Next, we open the floor to the participants, whose active engagement and contributions have made this conference a resounding success. We invite you to share your thoughts, experiences, and any reflections you may have regarding the conference. The student participants, the respondents, are requested to come to the stage.
So, good evening, one and all present here for the international conference. First, I would like to thank the principal and the college management and the coordinators and the staffs of the life science department of our college who worked tirelessly to organize such a wonderful international conference regarding the recent innovations in the health and biological sciences. First, the overall session, and also I'd like to thank the resource persons who gave a high caliber information about the research and how to present, and all the important things they have given to us was highly informative, and which will help us in our future research fields. And the overall session was highly informative, and the information which was given by the research persons are highly, how can I say, like, they ignited the curiosity of the people who are so enthusiastic in the science field. And overall, the session was so good and highly informative. And to conclude my feedback, I would like to thank for the given opportunity. And once again, thank you all. Sorry, I forgot to introduce myself. And this is Naveen Kumar, 3rd UG. For Arts and Science. Thank you.
Dear respondents, by response we meant feedback. Kindly and give your feedback. Introduce yourself and then begin.
Hello everyone. Good evening to one and all present here. I'm Vinitra, research scholar from University in the Department of Biochemistry. First of all, I'm super happy to be a presenter in this international conference on recent innovations in health and biological sciences. Amidst this great technical speakers and as well as the participants from various national participants, amidst this, it was a great opportunity for me to conduct various interactive sessions, and amidst this, in this WOW environment and atmosphere, I'm very happy to be a part of this conference. And with regards to the technical sessions, the topics were very relevant to the current scenario, and all the participants were able to connect easily, and all the topics were a need for the hour, and we as a researchers have to think about the research in this focus. And being an alumni in the Department of Biochemistry, very conference, and thank you everyone.
Respected dignitaries on the dais and off the dais, good evening to one and all. I am Dr. Tamilselvam, Assistant Director Biochemistry from National Ayurveda Research Institute for Panchakarma, Ministry of Ayush, Government of India from Kerala. This is a wonderful conference. The sessions are very, very wide. Different topics of life sciences have been covered. The conference accommodated not only the students but the scientists also. During the, even I have presented the paper. In that one, algorithm-oriented topics were also presented in the life science aspects. I have presented the paper related with the traditional Indian medicine system and their future. The topics related with computational biology have been presented. The basics of science have been covered by the eminent speakers. The animal aspects of laboratory animals and the future have been presented. So totally, the conference, I hope it met the objective. It is going to be a very, very useful for taking up the further projects. And as a scientist from the National Institute, we have recently conducted the conferences as a part of our Golden Jubilee celebrations. I never expected that the Arts and Science College would be able to conduct such a wonderful program in a timeline manner. Really, I am proud of this institution, the organizing. I keep my highest regards to them. And definitely, I am going to talk with my director to have a collaboration with this PSG organization. Initiated. Nice, madam. So it will be speeded up. Okay. Thank you for the opportunity given. Thanks, one and all.
Yeah, good evening one and all. I am Hema Priya, research scholar from BITS Pilani, Hyderabad. So today I would like to comment on this conference. Like, it was very informative and I am glad that I heard all these eminent speakers thought, and I would say like recent happenings in my own field, like I learnt it easily, and other fields also, like AI and computational biology, and I had the thought of like implementing AI in my area of research actually. And actually this is my second time attending the conference in PSG, and I also look forward to attend the rest few of them. Thank you so much.
Good evening one and all present on and off the dais. I am Harish Chandra, research scholar from ICAR Sugarcane Breeding Institute, Coimbatore. So first time I am coming to this conference under PSG campus, and I am also a proud alumni of PSG where I did my schoolings under PSG. The hospitality under PSG was very good. I have learned many new techniques, and I am very fortunate to present, and I am very fortunate to be in this dais in front of all these respected speakers. The time management was good, the organization was excellent, and I wished I will be participating in the next few conferences organized by PSG. Thank you.
Thank you, participants, for sharing your valuable insights and experiences. For those of you who could not share it here on this platform, kindly post it in the feedback link in the WhatsApp group. The reward for work well done is the opportunity to do more. Keeping this in mind, here is an announcement for 3 best papers and 3 best posters. I request the principal and the chief guest to distribute the certificates to the winners. First prize for oral presentation, Mr. Abhi Subesh, Unit of Microbiology and Immunology, ICMR, VCRC, Puducherry. Second prize, Mr. Raja N, Department of Food Safety and Analytical Quality Control Laboratory, CFTRI. Third prize, Mr. Gautam C., Dr. ALM, Postgraduate Institute of Basic Medical Sciences, Chennai. In the category of poster presentation, first prize goes to Southern Raj N., Savita Dental College Hospital, Chennai. Second prize goes to Dr. Gloria Jemmy Christabel R., VV Vanya Perumal College for Women, Virudhunagar. Third place goes to Mr. Arvind C. from PSG College of Arts and Science. From the Department of Biochemistry. Thank you, dignitaries. As we move forward, let's remember that knowledge is a continuous journey and the paths we tread lead us to new horizons. Today, we are privileged to have two eminent scientists who will share their expertise and experience with us. First, let me introduce our guest speaker, Dr. R. Kumar, Scientist G and Associate Director, Head of the Food Engineering and Packaging Technology Division at the Defense Food Research Laboratory, Defense Research and Development Organization in Mysuru. He is also heading Food Engineering and Packaging Technology Division. He has over 27 years of experience in food packaging, thermal and non-thermal technologies, and has completed 19 R&D projects. He also has undergone training on pulsed electric field application in food processing, experimental procedures and process evaluation at German Institute of Food Technology, Quankerberg, Germany. He has developed automation of tender coconut water processing system for large-scale production and processing of coconut sap. He has transferred retort processing technology to 85 industry, tender coconut water preservation technology to 36 industries, MRE ration technology to 15 industries, photodegradable packaging technology to 4 industries, and many more accolades. So I consider it a privilege to invite Dr. R. Kumar, a doyen in the field of food engineering, to enlighten us with his valedictory address.
Good evening to all. Respected Principal Madam, Dr. D. Brinda, Dr. Kadirvelu, Joint Director, DRDO BU Life Science Center. It is renamed as Defense Industry Academia Center of Excellence, Bharat University. Dr. Pon Mariyappan, scientist from DRDO Gwalior. Dr. Kamalakannan, Dr. Ramesh, and others in the dais, delegates, students, and the participants, speakers from the national, international academic institutes, R&D institutes. I am happy to participate and involve myself in this validity program. I will not take much time because already we are running late because most of them they started going. Conducting this kind of international conference, particularly in the field of life sciences, is very challenging. So I take this opportunity to congratulate the principal and the college management for choosing this topic, because now the current trend in the life science is towards strengthening your inputs in the R&D, where R&D can be useful to the society. Because I speak very openly, by publishing the papers, by getting the patents, we can improve our CV or you can improve your biodata. But what we expect, particularly people like us from the DRDO, we don't give much importance to the basic science because now the mandate of the DRDO labs, around 25% of the budget we upload to various academic institutes in terms of various R&D projects or establishing center of excellence. So far we have established around 16 R&D center of excellence, even including from Coimbatore to Chennai, Delhi, Hyderabad, Kharagpur, like that. So we now looking for the technologies or the basic science which can be translated into a maturity level where the process or the products can be easily converted into a large scale production whereby the users, for us the users are the Army, Navy, Air Force or the paramilitary forces where the technology or the other things can be achieved. We basically take research in the field of life sciences, particularly in the DRDO we have different technology clusters starting from aeronautics, missiles, electronics, combat vehicles, and of course in the computer science and electronic warfare, artificial intelligence, like that. But we in the life science cluster, as the department here, PSG College is having 9 departments. In DRDO also we have 9 laboratories in DRDO where we exclusively work on the life science areas. Because whatever the missiles you are develop, whatever the satellite you develop, or whatever the artificial intelligence you develop, you have to take care of the human being. Because whether the weapon is going to be handled by the human or whether the other aspects, the human plays an important role, both physiological, psychological, and then nutritional, and then environment where he is operating. Because our troops operate in different environmental conditions. Particularly when you go this peak summer, the temperature goes plus 55 degree in the Rajasthan sector. And if you go to the Himalayas or the Siachen base, because we have the different kind of neighbors. You cannot change your neighbor, what we say particularly. So we have the hostile neighbors where we are located in the China, Bangladesh, Pakistan borders. So you have to take care of your neighbors. When we are talking about the LOC, line of actual control or line of control, we need to have a different kind of strategy. So our troops operate in the different environmental conditions, minus 40, minus 50 degree, and then plus 50 degree Celsius also. So we provide the value to the Jawan or value to the sailors or submariners where his life will be comfortable because already he is away from the family, already he is away from these things. So by doing the life science research in different areas of starting from agriculture, high altitude agriculture, human physiology, and then biological warfare, all those things we take care of the country as a whole. For us, the users are the armed forces. What I expect or what my request or the thought process is, the academic institutes now not only doing the teaching alone will not end now henceforth, because now country is looking in the different dimensions. We can produce the graduates, we can produce the PhDs, but the academic institutes also should have a collaboration with kind of different R&D institutes and then with industries. One of the area where now we are looking for is the industry academia university collaboration. There is a big concept is now going on in DRDO as such. Maybe Dr. Pon Mariyappan might have spoken, but I will reiterate that DRDO is looking for the academia industry collaborations. That's why we are now looking for the partners in different fields. But our requirement or our concern is that we need a product or the technology. We don't look for any kind of other basic academic activities. So we will be looking for some kind of collaboration in the field of life sciences or any kind of DRDO relevance. So you can look for what are the things available with DRDO, and then we can these things. And we have this different kind of mechanisms where we fund the projects to different academic institutes. So the industry academia collaboration is very, very critical because now the countries calculating or talking about the ROI, return of investments. Today, suppose we invest 100 crores in the academic area or the academic universities, what is the return? We can calculate the return in terms of tangible and intangible. Tangible results, you produce the degree holders. Now currently the enrollment in Tamilnadu higher education is 54 plus something, where from 16% now we crossed it to 54%. But are the graduates, those who are coming from the different academic institutes, are what you call usable to the society, whether they are employable or what is their output to the society, that also you have to take care. So the R&D concept we calculate, we tolerate the TRL level, technology readiness level. So we start with TRL 1, TRL 2, TRL 3. Up to that, we are looking for the collaboration with academic institutes. TRL in the sense, you have to calculate the technology readiness level of availability in the country. For example, we also look for the collaboration in the terms of re-engineering or the indigenization. Now the present government is looking for completely stopping the import of weapons, ammunition, all those things. Though we are still not realized the self-reliance in these things. Even yesterday you might have seen the Chandrayaan 3 launch. Around 60 to 70% indigenous component is there, but still we are depending upon the other countries. So whenever we are talking about the R&D inputs in the country, you have to take care of the society as a whole. What is the sustainability in the research? By doing your research, how you can provide the solution to the society. Now you can see the climate change. Now the climate change is coming to a big way because of the indiscriminate use of the natural resources. You have to provide or you have to give something to the future generation. That's what the SDG goal says, sustainability development goals of UN things. Today, if you see Himachal Pradesh, or yesterday you have seen the Delhi, Yamuna river is crossing around 216 feet. It is now coming into the main city of the Delhi. Why it is? Earlier the days, the rain used to occur over a period of time, maybe 1 centimeter, 2 centimeter every day. But now today, at a stage, even a single day, 15 to 20 centimeter rain is falling in the earth because we have converted into urbanization. Now we have kind of concrete jungle we are living. So the climate change is playing an important role. Wherever you are using the climate, what you call the concrete and the air conditions, we are spoiling. So now we are talking about the carbon footprint also. So all these things come into the picture where you can provide the solution to the society. So the academic collaboration, when you are talking, it not only have a kind of networking you have to do. First thing, we have to see what is already available in the research area. What is the area which is not going to be these things? Now we are talking about the technology intensive organizations, whether we can use the AI, artificial intelligence, other whether you can use the machine language, or somebody was talking about the algorithms. And most of the life science labs or the life science departments also should use some kind of simulation and modeling before you go actually into the lab conditions, whether it is feasible. Instead of investing or instead of prolonging the time in the research lab, you can go for the simulation. Particularly now a lot of prediction software is available. Even in the microbiology, you can go for the prediction softwares where the pathogen level, whether it can withstand different environmental conditions. That is a predictive microbiology is also coming into the picture. So you have to use what you call the technology intensive tools in your R&D aspects. Most of the now we are talking about the CFD, all those things, computational fluid dynamics, everything. So wherever possible, the research would have a component of the latest technologies like artificial intelligence or the machine learning, which can have a more value, which will have a more kind of complete solution to your research problems. And another thing, when we are taking a research problem, please keep in mind what is the novelty in your any product or in any process. So we call the delta factor. So you should have a minimum delta factor of 3 and above, then only your research will have a more, what you call the output visibility in your, what you call your academic circle. And you can publish papers with high impact factor, but whether it will have a different, what you call the delta factor in your research. So the life science departments of this college or any college, you are coming from the different state governments or the private institutes, please keep in mind whenever you are formulating a research problem, have a kind of thorough review what is already done in your field and then go for the formulate the research problems. So that will help you to stand in this academic circle where you are going to survive, because nowadays the survival is the fittest concept, because unless you prove yourself in the research field, it is very difficult, because the research is fast growing. Earlier we used to tell in the 1960s, 70s, 80s, there won't be any research papers from China on any aspects. Today, if you see whether it is a polymer science or material science or medical science, you cannot imagine that they have not touched any area of these things, because they are putting an intensive effort in competing with the world developed countries, because the country as such is providing the solution to the society. So we have to emulate from the concept of Chinese these things. If you go and work with the Chinese professors, you will understand minimum they used to ask you to work minimum 18 to 20 hours. 18 to 20 hours, if you can work in the Chinese departments, then you will be asked to stay. Otherwise, the next day, they will be asked to go out, because their expectations are entirely different when we are talk about the Indian R&D system. So when you want to establish, particularly in the field of life science, it is a competition. Whether you start with the synthesis of gold nanoparticles from microbes or some botanical leaves, all those things, but whether it is having relevance to you, that you please take care of all those things. Particularly when you are coming to the DRDO concept, we are ready to do the funding. We have different mechanisms. Those who are interested, you can approach the concerned scientist here, Dr. Kadirvelu. But we have a very stringent mechanism screening all those things. We totally DRDO budget is around 26,000 crores. In that, we spend around 25% to the academic collaborations. We have different schemes in the DRDO for funding, but the funding mechanisms are very, very open, transparent. But only thing, the outcome we expect in a different way. We tell TR level 3 and above, if you have the proposals, we'll fund these things, because I don't want to spend much time about that. But the life science departments will play important role in the future, particularly after the pandemic. Because if you see the COVID pandemic, the life science has given a scope for the world that life science can also contribute to the humankind. No missiles or no weapons or no the other systems helped this country or the world to survive or to overcome this pandemic problem. Only the development of vaccines or development of other test methods, because India as such, Dr. Ponmariyappan aware that India, we didn't expect that this much magnitude of problem will come, but the life science labs or the life science R&D institutes came very quickly and provided the solution, because that is because of the contribution of the life science academic or the any R&D institutes. But similarly, the future is also in the life science only. Your lifestyle changes, your environment is changing, so you have to take care of the future requirements also, because you cannot predict there will be another pandemic or maybe after 20 years or 30 years. I'm not talking about the negative way, but we should have our base in the R&D aspects. So with this, once again, I congratulate the PSG College of Arts and Science, particularly the entire management team, for organizing a wonderful experience, this kind of international conference. And I'm first time seeing that after the conference, during the validity function, we are taking a feedback from the participants. Normally, we conduct the courses for the Army or the Navy officers, and then at the end, we take a formality for feedback for our future preference. But it is a very good sign that it is all coming to the accountability, and then how you can improve in the future when you are conducting some other conference. So, a nice way of doing this conference. And the time management also plays an important role. So I once again congratulate and thank all the organizers for giving an opportunity to participate. And anything we can provide, we will be ready, and we are willing to collaborate with any kind of academic institutions in the near future. But our expectations are entirely different than what the current academic institutes or universities are doing. So we talk about the milestone, mission mode, TR level, these kind of things. So please read the DRDO requirements. You can go to DRDO website and you can learn what are the things required from the academic this thing. And we are establishing different kind of methodology. Thank you very much.
Thank you, sir, for your insightful thoughts. Next, I will introduce our guest speaker, Dr. K. Kadir, Interim Director of the DRDO for Excellence, Bharatiya University, Coimbatore. He is a scientist at Defense Bioengineering and Electromedical Laboratory, Defense Research and Development Organization, Ministry of Defense, Government of India. He has more than 11 awards to his honor, and he is a fellow of the Royal Society of Chemistry. Kindly accept our invite and do address the gathering, sir.
Very good evening to all present here. Most respected Dr. Brinda Madam, Principal of this college, my colleagues Dr. Kumar and Dr. Ponmariyappan, at Kamalakaran, other HODs, guests, faculty members, student friends, once again, very good evening to all. I will not take much time because, as you know, already we are running out of time. But you see, yesterday we had two guests, eminent guests. One is from Planning Commission, another one is from Chancellor,
not only Chancellor, he was a Director General for 10 years in DRDO. They given very clear message to the youngsters. Especially you see our India is transforming in very fastest manner. When you have this kind of developments, infrastructure development, technology development, there will be a competition for the resources, especially natural resources. And also other side, you know, we have a commitment by our government of India in the international forum, that is COP 2015, Conference of Paris at 2015. So India is committed to reduce our CO2 emission by 30% 2030 and zero in 2070. So other side, you know, we have a lot of damages, depletions of environmental resources, competitions. So how you are going to achieve? So these are all big challenges. So before by starting my few points, first let me put my appreciation and congratulations to the entire team for conceiving such an excellent idea, where our speaker, previous speaker, Dr. Kumar, and yesterday our Dr. Salumurthy and even Professor Ismail, they were told about it is going to be a year of life sciences. So, and also not only that, now if you, whatever R&D you do now, you will not be able to do it in an isolated platform or even compartment. Now it's completely become multidisciplinary. So by connecting this kind of 9 departments, life science departments, is an excellent opportunity for the youngsters. When you after conference, when you go home, try to keep your contacts from other departments to take the help from the other departments to make an excellent R&D. As I mentioned by our previous speaker, we must work beyond, starting from hypothesis to beyond tier level 3 or 4, and also try to protect our IPRs. So that way, it is one of the excellent platform given by this management, especially under the leadership of Madam. Madam, congratulations, appreciations. So it is excellent event, there's no doubt. And coming to the point, see now, as I just now, one of my colleague is given a point. See, my previous speaker, Kumar, has mentioned about how we are able to support this government, public, especially during the disaster, COVID time. So especially life science lab, especially from our organization, we give 50 plus technologies to the society. Especially if you look at the Coimbatore as a region, we all should feel proud because we have supported the excellent support to this country. Few example, the technology developed for fighter pilot, that is called onboard oxygen generation system for fighter aircraft Tejas, the same being converted as a medical oxygen plant by the support of the industries in Coimbatore, that is called Trident and Summits. For entire country, every district headquarter, we have got 1,000 liters per minute oxygen generation, medical oxygen plant. This is a great support by this from this place. And also yesterday again our chief guest mentioned about the ventilator, how we developed in the Coimbatore. Again being used in the first wave. So like that, a number of technologies gone from this place, as well coveralls, identity mask, everything is gone from this such a way. So don't underestimate life science is nothing like that. No, we are timely support this country, and also a lot of opportunity available. And if you look at futuristically, if you wanted to work on the new areas, especially in the health, see now today like CRISPR technologies, CRISPR DNA editing technology. So a lot of things are coming up, especially when you are doing this kind of technology. You have to take care of the ethical issues. You know what happened in 2020 at China. They left the designer baby, so they are all prosecuted. So we need to be very careful when handling this kind of technologies. And also, you see today that point of care 3D manufacturing technology. In 2010, US there are only 3 hospitals in this facility. They are able to develop the the dental implants, bone joints. Now the R&Ds are on, like artificial skin, even organs, like that thing, even medication things are happening. And again, now they got 120 hospitals are having this kind of point of care. So the way things are happening is amazing. And also when it comes to the other AI and other aspect, if you see one example, if you enable AI with, you can review your mammogram result 30 times faster with 100% precision. So you see the way things are happening. And also you come to the now recently for Stanford University, if you see the bandages with the smart bandages and with sensors, how you can cover the wound and also give the supply the blood tissues to the damaged tissues, like that, and also how to avoid this to work towards your fellow colleagues who are in the other domain. So I think there are a lot of opportunities are there. I'm sure. Even computer sciences like that. So I think without taking much time, so I once again thank my alma mater and team for giving me opportunity to come over here, share some of experience. As mentioned by my previous speaker, so now we are pumping 20% funding to the academia from our budget, as we mentioned, by 20,000 crores. So you have to come forward, and also you have with clear ideas where you will have to deliver certain valuable R&D beyond your technology readiness level 3 or 4, so that you can support this country to become now, especially developed country or super country, where the country can enjoy the global power. When you become global power, we have to globally responsible country. So all these things are required to be responsible. You have to have in-house R&D. So that's why thank you very much for the opportunity. Thank you, madam. Thank you, everyone. Thank you.
Thank you, sir, for your words of wisdom. PSG College of Arts and Science publishes 2 in-house journals, one for social sciences and the other is Science and Technology Journal, namely PSGCARE Search, which is a biannual journal published since 2014. We are proud today on this memorable occasion to release its 4 concurrent issues. I request the editor of the journal, Dr. Victor Arokyadas, Associate Professor and Head, Department of Biochemistry, to hand over the issues to the Chief Editor, our Principal, Dr. D. Brinda, who is requested to hand it over to the Chief Guest. I invite the Chief Guest to release the PSGCARE journals. Thank you, dignitaries. Respect is earned, but honor is given. I request our principal to honor the chief guest for their valuable time and presence with us here on this memorable occasion. We kindly request Dr. Paripon Estranwat, Assistant Professor and Head of the Department of Biotechnology at Mahasarkham University, Thailand, to graciously accept a token of gratitude as a memento during this international conference. admiration and gratitude, we invite Dr. Kalpani Ratnayake, Deputy Head of the Faculty of Health Sciences at Colombo International Engineering College, Sri Lanka, to accept a special memento as an expression of appreciation. We humbly request Dr. Seranathan Kamalakannan, Professor in the Department of Biotechnology at Jeonbuk National University, South Korea, to kindly receive a token of gratitude and honor as a memento during this notable international conference. Sir and Madam, for doing and receiving the honor. As we approach the end of this remarkable journey, I request Dr. N. Krishnaveni, Assistant Professor and Head of the Department of Microbiology, to propose the vote of thanks.
Good evening to all the learned members of Biological Sciences fraternity. The International Conference on Recent Innovations in Health and Biological Sciences has marked its place in the history of PSGCARE with deliberations on the research and applications in the constantly changing and advancing world of life sciences. There has been a huge list of contributors for an event with such a massive takeaway. It's our duty to propose the vote of thanks to every individual who contributed to the conduct of this international conference. It's my privilege to have been asked to propose the vote of thanks on this occasion. I, on behalf of PSG College of Arts and Science and the organizing members together, extend a very heartfelt gratitude to all the speakers for sharing your significant contributions to the scientific community and sharing with us your findings and opinions. We submit our sincere thanks to our esteemed Managing Trustee, Shri L. Gopalakrishnan, for the support and able leadership motivating all of us to take bold steps to put forth PSG in the forefront for all the academic and research endeavors. We are humbled and submit our heartfelt thanks to all our chief guests and keynote speakers who were the showstoppers for the program. We record our sincere thanks to Dr. W. Selvamurthy Sir, Amity Directorate of Science and Innovation, Chancellor of Amity University, Chhattisgarh, Professor Sultan Ahmad Ismail, Member State Planning Commission, Government of Tamil Nadu, for inaugurating the two-day conference and initiating the scientific deliberations with their rich experience. We thank all the international keynote speakers, Dr. Chang Woo-ji, Chonnam National University, South Korea, Dr. Kalpani Ratnayake, Colombo International Engineering College, Colombo, Dr. Pariyapon, Mahasarakkam University, Thailand, Dr. Seranathan Kamalakannan, Jeonbuk National University, South Korea, for accepting our invitation, for sharing their knowledge and expertise and unveiling the futuristic research approach to the next generation learners. We submit our gratitude and thanks to all the keynote speakers from reputed institutions of our country. Dr. Nareen Ramanan from Indian Institute of Science, Bengaluru, Dr. Pon Mariyappan Swami, scientist from DRDO Gwalior, Professor Shankar Ganesh from BITS Pilani, Hyderabad, Dr. Kadirvelan, Tamil Nadu Veterinary and Animal Sciences University, Namakkal, Dr. K. Ramesh from Aditya Birla Group, Mumbai, Dr. S.P. Muthukumar from CFTRI, Mysuru, for their special lecture sessions and inspiring the young bioscience graduate. The sessions by these lead speakers, panel discussions, and the repertoire made by the session chairpersons have clearly portrayed the strategies, activities, and techniques on which the life science graduates have countless opportunities of learning and exploring their opportunities by interdisciplinary approach. We sincerely thank all the delegate speakers and session chairpersons for your thought-provoking scientific interrogations and deliberations. We record our sincere thanks to our respected Secretary, Dr. T. Kannayan sir, for all the encouragement, guidance, support, and freedom to execute an event of this significance. We submit our humble gratitude and thanks to our beloved Principal, Dr. D. Brinda Madam, for envisioning this conference theme and mentoring the entire team and providing entire guidance. We acknowledge your vision and ability with humbleness, Madam. We must say that your incredible guidance, timely and proper hand-holding, and freedom given to the organizing team provided a great motivation in organizing the conference to this success. The minute-to-minute guidance and support encouraged at every point for the organizing team. We submit our heartfelt thanks to our Vice Principals, Dr. Anguraj, Dr. Jayanti Madam, Dr. Umarani Madam for their support and encouragement for conduct of this conference. We submit our hearty thanks to the Chief Guests of Valediction Program, Dr. R. Kumar, Scientist G, and Associate Director, Head Food Engineering and Packaging Technology Division, DFRL, DRDO, Dr. K. Kadirvelu, Scientist F, Interim Director, DRDO Industry Academia Center of Excellence, Bharatiyar University, Coimbatore, for their valuable insights. This is the most opportune moment to express our profound gratitude to this august assemblage of guests who partook the glory of this conference. Our special thanks to all the sponsors and partners for the program. All this success would not have been possible without the financial support by PSGCARE, Indian Immunologicals Limited, Hyderabad, DRDO, Tamilnadu State Council for Higher Education, Tamilnadu State Council for Science and Technology, and the international affiliate of the Academy of Nutrition and Dietetics, Chicago, Illinois, USA, for their major contribution and sponsorship. We recognize with gratitude their significant contribution for the conduct of this program. We record our hearty thanks to the program sponsors, Collaborative Healthcare Foundation, GX Fashion, Solros Products, Bluestone Overseas Consultants, Sistron Biological Laboratory, Salem Microbes Private Limited, Microbiotech, ORPL Bioscience Private Limited, Technico Laboratory Products, Genesis Lab Instruments and Chemicals, Precision Scientific Company, JM Scientific Company, Universal Scientific Company, Modern Scientific Company, Research Supporters, Chennai, One World Hillock Institute of Nature, and Ratan Laboratory and X-Ray Cafe. I thank the organizing secretaries, Dr. B. Ramesh, Dr. Sendil Kumar, for their tireless effort in guiding every team member for meticulously planning the execution of the conference. Our hearty thanks to all the joint secretaries, Dr. Radheshri, Dr. Sengutuvan, Dr. Victor Arogyadas, Dr. Uttara for their efforts and careful planning. Our special thanks to the organizing coordinators, Dr. Mohandas, Dr. Shanti, Dr. Danakumar, and Dr. Syed Ibrahim for their outstanding efforts and contribution. I record our profound thanks to all the heads of the departments and faculty members of participating life science departments for their fullest cooperation and execution in the conference. I wish to acknowledge the devoted endeavors of every member of the organizing committee, other staff members, and all the volunteers. They all have striven hard, taking time to execute the assigned task and the hospitality for the conduct of this conference. We have witnessed the drastic transformation in mindset of young researchers, proving that India will soon climb up from the 40th place in Global Innovation Index to the top 10, as portrayed by our chief guest, Dr. W. Selvaraj sir. As mentioned in the report, there had been overwhelming response from participants across to showcase their scientific findings. We record our heartfelt thanks for the active participation and presentations in the oral and poster presentations. It speaks volume about the zeal and enthusiasm of all the participants to learn, share, and disseminate learning. I take this opportunity to thank all the faculty members, research scholars, and students from other institutions and PSG College of Arts and Science, music department and the club, NSS student volunteers, cultural committee members, cast crew, faculty members and team for the excellent cultural performance. Special thanks to Dr. Bharati Madam for doing the MC for the 2 days. I thank all the supporting departments of the college, Administrative Officer Mr. Mohan Raj, Administration Department, Finance Section, Infrastructure Support, Maintenance Department, Food Court, Guest House, Jade and PSG Annex members, Transport Office, support staff of PSGCARE for all the help and support for arranging for the event. Our sincere thanks to the press and media for wide coverage of the event. I thank all the participants for the active participation and valid discussions. Once again, I thank all the members who were part of this conference for forging a longer association with our institution. It's a great honor for PSGCARE for having such prominent speakers known for their great contributions in their respective research fields. Thank you, one and all. Thank you.
All are requested to kindly rise for the national anthem. Participants from other institutions are requested to collect their certificates from the registration desk. One participant from each institution is requested for the collection of certificates. Participants from PSGCARE can